All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, boys and girls, in the today's session, we will be completing the rest of the class 12th portion. Okay. And this session is extremely important, my dear NEET aspirants, because whatever the chapters we have in this particular session are having the extremely huge weightage that I must say. Okay. So, boys and girls, what I want you to understand in this particular case, is that make sure everybody of you stay with me till the end, because we will be starting from the scratch and I will take you to the level which you actually need. And my dear NEET aspirants, when it comes to the number of chapters that we are going to cover in this particular session, okay, it is going to be, I would say, first modern physics, dual nature of matter and radiations, then atoms, then nuclei, then semiconductors, then ray optics, and then we have the wave optics. And my dear NEET aspirants, when it comes to the duration, it is going to be 6 hours. That's it. 5 to 6 hours, I would say. 5 to 6 hours. Okay. That's it. In the next 5 hours, we are going to complete the entire session. But make sure you stay till the end. Okay. Because when it comes to the modern physics, okay, these 4 chapters, 11 questions are asked approximately every single year. And here, this is, I would say, 5 questions over here from this particular portion. Means total of 17 questions. Yes, and when it comes to the notes I'll be sharing. Okay, I know part 1 of class 12th as well as part 2 of class 12th. I'll be sharing both in the Telegram channel today itself. Yes. In the Telegram channel, I'll be sharing. Make sure you join the Telegram channel, that is t.me /Yawar Yawar Manzoor. And there is one more Telegram channel. If you don't find any of the PDFs over here, then there is one more channel where you can find it. That is t.me /Unacademy UNACADEMY Unacademy NEET English. Okay. So these are the Telegram channels. This is the Telegram channel where I share everything. And if you don't find any of the notes over here, then you can find the notes in this Telegram channel. Okay. Everything I will be sharing, my dear NEET aspirants. But make sure you stay till the end, because I am going to start everything from the scratch. Now, boys and girls, listen to me very carefully. First, we will be starting with the modern physics portion. That is dual nature of matter and radiations. Then we will be move on to the rest of the chapters. Let's begin with the first chapter. Make sure you smash the like button, because liking the session means marking the attendance. Okay. Yes. Now, guys. Okay. In this particular case, I'll become whatever the chapters we have incomplete in class 11 portion, I'll take next part of this one. I'll complete those. Don't worry about that. Right now, focus on this one. My dear NEET aspirants, when we talk about dual nature of matter and radiations, listen carefully. We discuss about light. Listen, guys. If I say, let's suppose I have a light source over here. This is a light source. Light source means that source which gives light. Let's suppose this is a bulb, light source. From this light source, my dear NEET aspirants, if I say light is coming out, is this light a particle? Are these particles coming out? Basically, are these waves coming out? My dear NEET aspirants, we know light has got dual nature. But in this particular chapter, we will be assuming light as a particle. Okay. So in modern physics, in wave optics, we'll be assuming light as a wave. But when it comes to the modern physics, if I say this is a light source and this is light coming out of this, so this light is what we call particles. And these particles are what we call photons. Photons. So from now onwards, in this chapter, we'll be remembering that light is made up of small, tiny particles. And those small, tiny particles are what we call the photons. Okay? Those tiny particles are what we call the photons. These are photons. So from now onwards, if I say light is falling on my hand, so it means these are the photons falling on my hand. If I say this is energy falling on my hand, means these are the photons falling on my hand. So light is simply photon. So the first topic of dual nature of matter and radiations, that is itself the energy of a photon. Guys, I'll be very short and precise. Make sure you give me 100% of your attention. Everybody. First is energy of a photon. My dear NEET aspirants, we say energy of a photon is simply H into F. H means what? Planck's constant, and F is what? Frequency. Directly remember. When Planck's constant is multiplied with frequency, it gives you the energy of a photon. It gives you energy of a photon. So my dear NEET aspirants, you can say E is equal to H into F. This is energy of a photon. Then further we say this F frequency is equal to C divided by lambda. C means speed of light. Lambda is de Broglie's wavelength. And if you put it over here, it becomes what? It becomes hc divided by lambda. It becomes hc by lambda. Okay. And my dear NEET aspirants, you must know that when it comes to this H, Planck's constant, its value is 6.6 into 10 raised power minus 34 joule second. And speed of light is 3 into 10 raised power 8. And when you put the values, guys, when you put the values, the energy of a photon comes out to be like this also. Please directly remember. Directly remember. Energy of a photon, we say H into F. And then we can also write it hc by lambda. C is speed of light, lambda is de Broglie's wavelength. And when you put the value of Planck's constant, speed of light, it comes out to be energy of a photon, 2 into 10 raised power minus 25 by lambda. This is in joules. This is the energy of a photon in joules. This is the energy of a photon in joules. Now, my dear NEET aspirants, like you measure mass in kgs, listen carefully. Let's suppose if I say you have got mass m is equal to 1 kg. You also say, sir, mass is equal to 1000 grams. So kg is also a unit, grams is also a unit. Similarly, you measure energy in joules as well as you measure energy in electron volts. So please directly remember. So this is the energy of a photon in electron volts. Okay, 1240, but lambda you take over here in nanometers. This is the energy of a photon in electron volts when lambda is in nanometers. And this is the energy of a photon in electron volts, but when lambda is in angstrom. Sir, when should we use this and when should we use this? Take a look, my dear NEET aspirants. Let's suppose you have got a photon. This photon has got wavelength of, let's suppose, 4000 angstrom. You have to find its energy. And my dear NEET aspirants, let's suppose you have got, in this particular case, a photon. Its wavelength is 310 nanometers. And I am asking you, what is the energy of this photon? Sure. And you have to find the energy in electron volts in both cases. Now, guys, when you have to find the energy in electron volts, you have these two equations, this one and this one. But you have to see, If lambda is given in nanometers, then you will be using this. If lambda is given in angstrom, then you will be using this. So in this particular case, it's an angstrom. So we'll be using 12400, okay, divided by lambda. Lambda is given as 4000 angstroms directly. And when lambda is given in nanometers, you'll be using 1240 divided by lambda. Lambda is 310 nanometers. So this is how do we use these two particular equations in this particular case. Are you getting me, guys? Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats, everybody out there. Now, let's suppose, yes, I'll be sharing the class 12 part 1 notes also, part 2 notes also after this marathon, please. Okay, wait for the notes. I'll share for sure. Now, my dear NEET aspirants, what is the energy in joule? What is the energy in joule? You have to find the energy in joule associated with a photon. Associated with a photon of wavelength 4000 angstrom. Let's suppose, my dear NEET aspirants, you have a photon over here. It has a wavelength of 4000 angstrom. You have to find energy in joules. Okay. Now, whenever you have to find the energy in joules, you will be using this particular formula. 2 into 10 raised power minus 25. But lambda here is in meters. Keep this thing in your mind. Lambda here is in meters and energy is in joules. So you will be like, sir, I can say in this particular case, energy will be 2 into 10 raised power minus 25 divided by lambda. Value of lambda is 4000. But since it is in angstrom, you have to convert this in meters. So you will be multiplying with 10 raised power minus 10, because we say 1 angstrom is 10 raised power minus 10 meters. 1 nanometer is 10 raised power minus 10, 10 raised power minus 9 meters. This is how you are going to write it. Okay. So 2 into 10 raised power, I would say, minus 25 divided by 4000 into 10 raised power minus 10, because you have to find this particular energy in joules. This will be the energy in joules in this particular case. Okay. So my dear NEET aspirants, you can say when you divide 0.5 into 10 raised power minus 18 joules. Okay. This will be the energy in joules. And my dear NEET aspirants, in the same question, if you have to find the energy in electron volts, if I say energy in electron volts, then you will be using this. Lambda is given in angstrom, you will be using 12400. Divided by lambda, lambda is given as 4000 angstrom. Okay, directly it will come out to be 3.1 electron volts. This is in joules, this is in electron volts. Absolutely. Then comes the energy of light, boys and girls. Take a look, my dear NEET aspirants. Let me make you understand energy of light. Just a second. Take a look. My dear NEET aspirants, let's suppose if I say I have got a light source over here. This is a light source. If I say from this light source, this light is coming out. This light is coming out. So when I say this is light, how many photons are there in light? 1 photon, 2 photon, we say there are n number of photons. Okay. There are n number of photons. So when I say energy of light, it means energy of. So when I say light, it means n photons. You directly write it. Okay. So if I say energy of 1 photon, what is the energy of 1 photon, boys and girls? I recently told you, energy of 1 photon is hc by lambda. Energy of 2 photons is 2 hc by lambda. energy of n photons will be nhc by lambda. This is how we define as energy of light. This is how we define as energy of light. nhc by lambda. Okay, as simple as that. As simple as that. This is, and where n means number of photons, h is Planck's constant, c is speed of light, lambda is de Broglie's wavelength. Then we define power of light, my dear NEET aspirants. What does power of light actually mean? Listen carefully. When we define power of light, I want you to understand over here one thing. Let's suppose, boys and girls, you have got a bulb over here. You have got a bulb over here. You have one more bulb over here. If I say this bulb is also giving light, this bulb is also giving light. So this is the light given by this bulb. This is the light given by this bulb. This is the light given by this bulb. Okay? Yes. And when I say bulb given, a light given by this bulb, it is this. What is the difference between the two? Sir, this is giving large light. This is giving less light. So means large number of photons are coming out of this bulb. Less number of photons are coming out of this bulb. What does that mean, my dear NEET aspirants? That means every second, this is sending large energy. Every second, this is sending large number of photons. So power of this bulb is large. Let's suppose this is A and this is B. I would say power of A is greater than power of B. So power simply means how much light is coming out of the bulb every second. How many number of photons are coming out of this bulb every second. So we define this power as energy upon time. Okay, how much energy is coming out every second. How much is the energy? NHC by lambda, NHC divided by lambda, and time is, we say, T. This is the formula for power. NHC by lambda into T. This is the power in this particular case. Okay. Then we define intensity, my dear NEET aspirants. Listen carefully, I'll make you understand what intensity is. Power means how much light is coming out of the bulb every second. And when we define intensity, boys and girls, let's suppose you have this bulb over here. You have this bulb over here. Now, if I say you place a plate over here, from this bulb, light is coming out. This is the light coming out of this bulb. This is the light coming out of this bulb. Okay. Sorry. This is the light coming out of this bulb. If I say, my dear NEET aspirants, if I say every second, how many number of photons are coming out of this bulb? Sir, large number of photons every second. Every second, how many number of photons are coming out of this bulb? Less number of photons. So if I say you take a unit area over here, on this unit area, and if I say you take a unit area over here, now on which unit area large number of photons are falling or large energy is falling, sir? Obviously this one. So I would say intensity at this point 1 is greater than intensity at point 2. So when you define intensity, you see how many number of photons are falling every second per unit area. Guys, what is the difference between power and intensity? Power means how much energy is given by the light. How much energy is given by the light. Intensity means how much energy this bulb is giving, this light source is giving, and how much it is reaching at a particular point. Like this is a bulb, this is a bulb. Sir, at this point, energy is large because of the bulb. At that point, energy is less. So means intensity of the light at that point is less. So when you define intensity, you define place also. Okay, area also. Energy per second per unit area. How much energy is falling every second on this unit area? That is intensity. Intensity here will be large. Intensity here will be less. So you directly remember, boys and girls, when you define intensity, it is energy upon time into area. So energy upon time is power. So we say power divided by area. Just a second, guys. Just a second. Just a second. Just a second, guys. Is this clear till over here? Is this clear till over here? Tell me quick. Is this clear? That's great. I'll be sharing the notes also. I'll be sharing the notes also. After this session, I'll share the notes. That's for sure. 100%. Okay. So we defined intensity. So how can you now say this intensity? Sir, intensity is N number of photons Hc divided by lambda. This is energy. Okay, this much is energy. Okay, this much is energy divided by time divided by area. This area, this is what we call intensity. Okay, so you can also say C by lambda is also F. So NHF divided by A into T. This is the intensity. This is the intensity. Energy per second per unit area. Now, guys, what is important in this particular case is what we call the photoelectric effect. I want you to understand this very carefully. My dear NEET aspirants, let's suppose, listen carefully, what does photoelectric effect mean? I'll give you the proper feel of photoelectric effect. Let's suppose, my dear NEET aspirants, you have got a metallic surface over here. This is a metallic plate. And you take a light source over here. This is a light source. From this light source, I would say light is falling. This is light falling. We are doing this experiment. When light falls on this metallic surface, we say electrons present in the metallic surface are ejected. This is a light. When these photons fall on the metallic surface, electrons are ejected from the metallic surface. Okay? Electrons are ejected from the metallic surface. This phenomena in which light falls on the metallic surface, photons fall on the metallic surface, due to which electrons are ejected. This phenomena is what we call the photoelectric effect. When light falls on a photosensitive metallic surface and electrons are ejected from the surface, this process is called photoelectric effect. This process is called photoelectric effect. Now, my dear NEET aspirants, you have a concept work function. We have to understand photoelectric effect in detail. Just give me a second, I'll make you understand work function. Work function means minimum energy required to pull the electrons from the metal surface. Like. Take a look, guys. Let's suppose you have a metallic surface over here. This is a metal surface, material. If I say work function is represented by pi. Let's suppose its work function is 2 electron volts. What does it mean? It means that if you have to pull the electron out of this metal surface, how can you pull the electron out of the metal surface? When you send the light, when you send the photon. So the photon which you are sending, it must have the energy equal to, I would say, 2 electron volts, equal to work function. Okay, or greater than work function. Sir, what if it has energy less than work function? Then it cannot pull out the electron from the metal surface. Then this photon cannot pull out the electron from the metal surface. This photon can only pull out the electron from the metal surface if its energy is equal to the work function. So work function depends upon the material. Like if I say work function of this material is 5 electron volt. So in order to pull out 1 electron from this metal surface, we must send an electron which has the work function of 5 electron volts, which has an energy of 5 electron volts. So this is the minimum amount of energy required to pull the electron from the metal surface. Okay, like for this metal, if I say work function is 5 electron volts. So if you have to take out the electron from this metal surface, you must send a photon which must have the energy of 5 electron volt. If it has 4, it cannot pull out the electron. This is how we define work function. So different materials have got different work function. Different metals have got different work function. I believe this is clear. Now guys, experimental setup of photoelectric effect. Experimental setup of photoelectric effect. Listen carefully, because from this portion, you can expect the question, my dear NEET aspirants. That is experimental setup of photoelectric effect. Take a look. I would want you guys to focus exactly over here. Boys and girls, whenever you have to basically do this photoelectric effect, you make a proper setup for this. Like, you take a tube-like structure. This is a tube-like structure. And you keep the opening over here. This is the opening. And there's a light source from which photons are coming. Now, my dear NEET aspirants, please listen carefully. This is the metal surface present inside this tube. This is called cathode. And there is one more metal surface present inside the tube. This is called anode. When the photons come out of this light source, it fall onto this cathode metal surface. We know, sir, we know the photoelectric effect. Whenever photons fall on the metal surface, electrons are ejected. So my dear NEET aspirants, in this case, electrons are ejected from the metal surface. Okay? Yes. Now listen carefully. I want you to understand this very carefully. Let's suppose you are sending a photon which falls onto this metal surface. Okay. Let's suppose energy of this photon is 8 electron volts. And work function of this metal, work function of this cathode is 2 electron volts. What does that mean? That means if you have to pull out the electron from this cathode, how much energy is required? 2 electron volts. But how much you are giving? 8. You are giving much large. Okay, sir. Now, when this photon will strike with the electron over here inside this metal surface, now the electron present inside this metal surface will get how much energy? 8 electron volts. Because photon will transfer the energy to the electron. Now electron has 8 electron. Electron has got how many, how much energy? 8 electron volts. So this electron is going to use 2 electron volts to come out of the metal surface. Electron is going to use 2 electron volts to come out of the metal surface, because that is work function. Work function is 2. Now how much is remaining? 6. When this electron comes out, okay, so in order to come out, it has used 2 electron volts. Now still it has got 6. With the help of that 6 electron volt energy, it will move forward, my dear NEET aspirants. It will move forward. It will move forward. So that will go into the kinetic energy of the electron. So can I make the equation? Energy of the photon is used in work function. Work function means to come out of the metal surface. And rest of the energy as kinetic energy to move forward. Because it has to move forward, it has to create current. So we can say energy of a photon is equal to work function plus kinetic energy maximum. This is called Einstein's photoelectric equation. This is called Einstein's photoelectric equation. Okay. This is called Einstein's photoelectric equation. Now, my dear NEET aspirants, let me make you understand the graph over here, which is very important. Listen carefully. Let's suppose if I'm saying this is the cathode. Okay. When photons fall onto this cathode, electrons come out of the cathode. Yes, sir. Let's assume that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons came out of the cathode. Let's assume that. 10 electrons came out of the cathode. Now, my dear NEET aspirants, out of these 10 electrons, I would say 1, 2, 3, 4. Only 4 electrons are able to move forward. Okay. Reach anode. This is anode. Only 4 electrons by itself. Why? Sir, it is because those 4 electrons are having the large energy. And those 4 electrons are not facing any sort of collisions over here. Guys, please listen carefully. Please listen carefully. I would say, sir, 10 electrons are coming out of the cathode. Sir, does that mean all the 10 will reach anode? No. Sir, these 6 electrons are facing so many collisions that they are not able to reach anode. So only 4 are able to reach anode. So what we do, my dear NEET aspirants, we connect a battery. We connect a battery. When you connect a battery, this is the positive terminal of the battery. This is negative. Positive terminal of the battery connects positive charge over here, my dear NEET aspirants. It creates positive charge over here. Battery has got potential, EMF. When battery was not connected means when EMF was 0. Battery was not connected means when EMF was 0 volts. How many number of electrons were reaching anode? 4. So when electrons move, we say current is being produced. At that point of time, we say photocurrent. Guys, listen carefully. When these electrons move, they produce current. That current is called photocurrent, because this is because of the photons. So in that particular case, photocurrent was how many number of electrons were moving? 4 electrons were moving on its own. Now let's suppose you connected battery. EMF of the battery is 10 volts. Let's suppose when 10 volts you are connected. Now some positive charge is created. So now it will attract one more electron. Now 5 electrons are moving. Okay. 5 electrons are moving. Now, my dear NEET aspirants, what I want you to understand in this particular case, you increase the potential difference, EMF. You make it 20 volts. So when you make 20 volts, now more positive charge is created over here. It will attract one more electron. Now 6 electrons moving. Similarly, my dear NEET aspirants, okay. Similarly, when you apply 30 volts, we say now 7 electrons are moving. More positive charge are created in this case. Sorry. Okay. Now, boys and girls, We say when you apply 40 volts, 8 electrons are moving. When you apply 50 volts, I would say 9 electrons are moving. When you apply 60 volts, I would say 10 electrons are moving in this particular case, my dear NEET aspirants. Okay, so positive charge, positive charge, positive charge. So means all the 10 electrons are moving. Now if you even further increase 70 volts, only 10 electrons will be moving. Why? Because only 10 electrons came out of the cathode, my dear NEET aspirants. Now, this moving of electrons, motion of electrons is called photocurrent, and this is EMF. Now, if you make the graph between photocurrent and EMF, listen carefully, that would be something like this. See, this is EMF and photocurrent. So when EMF is 0 volts, at that point of time, already how many electrons were flowing? How many? 4. So photocurrent was not 0. So 4 electrons were moving. So that's why the graph starts from this point. And it goes and becomes constant. So here, let's suppose 10 volts, 20 volts, 30 volts, 40 volts, and 60 volts, 70 volts. At 60 volts, my dear NEET aspirants, this photocurrent becomes constant. This photocurrent becomes constant, 10. So that's why the graph is something like this. Are you getting me, guys? Is this clear? Is this clear? Is this clear? Tell me quickly in the chats, everybody out there. Now, my dear NEET aspirants, if you do one thing, what is that? If you reverse the polarity of the battery, listen carefully. This is cathode and this is anode. How many electrons were moving forward? 4. So when potential difference was 0, when EMF was 0, so how many photoelectrons means photocurrent? We say 4 electrons were moving forward. Now, my dear NEET aspirants, when you reverse the polarity of the battery, listen carefully. Reversing the polarity of the battery means positive from this side, negative from this side. Now, when you reverse the polarity of the battery, my dear NEET aspirants, it is going to create the negative charge over here. Let's suppose you applied minus 10 volts. So now some negative charge will be occupied. Now this negative will repel these electrons. Electron have got negative charge. I'll explain stopping potential now. Wait. Now, my dear NEET aspirants, when minus 10 was applied, so some negative charge is going to repel these electrons. Now only 3 electrons are able to reach anode. Why? Because now electrons are facing repulsion. Now electrons are facing repulsion. Let's suppose you applied minus 20 volts, my dear NEET aspirants, on more negative charge on cathode. Now 2 electrons will face more repulsion. So only 2 electrons are able to reach. Let's suppose you applied minus 30 volts, only 1 electron are able to reach. Minus 40 volts, now all 4 are facing maximum collisions. 0 electrons are able to reach cathode. Can I say in this particular case, photocurrent becomes 0? At this negative potential, when all the electrons face maximum collisions, we say at that point of time, photocurrent becomes 0. This potential is what we call stopping potential. Stopping potential. This potential is what we call stopping potential. Now, guys, if you increase the EMF from on the negative side, minus 10 volts, photocurrent will decrease. Now only 3 electrons are reaching anode. Again, minus 20 volts, again photocurrent decreases. And then when you apply minus 40 volts, I told you over here in this particular question, at minus 40 volts, you see photocurrent is 0. And this potential is what we call the stopping potential. And at that potential where no electron flows from cathode to anode, that is what we call the stopping potential. Please tell me in the chats if this is clear. Guys, quick. And smash the like button if you're not liked the session yet. Yes. So this is the graph of photoelectric effect between photocurrent and EMF. Okay, between photocurrent and EMF. Okay. Yes. 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 That's great. That's great. So my dear NEET aspirants, you can say energy of a photon is equal to work function plus kinetic energy maximum, Einstein's photoelectric equation. One more important thing, you can write this energy of a photon like this also, h into f, Planck's constant into frequency. Work function is also energy, my dear NEET aspirants. You can also write h into f naught, where f naught is the threshold frequency. Threshold frequency. Minimum frequency at which photoelectric effect takes place, at which electron comes out of the metal surface, that is threshold frequency. Like this is minimum energy, this is minimum frequency, plus this E, kinetic energy maximum, you can write EV naught. V naught is the stopping potential. E is the charge on an electron. This is also how we can write this particular equation. Okay. Even you can write it like this also. Take a look, guys. You can say, guys, F is C by lambda. So HC divided by lambda. It will be HC divided by lambda naught. Plus I would say EV naught. You can write it like this also. Yes. Like this also. And my dear NEET aspirants, I can say, listen carefully. This equation, you can write it like this also. Energy of a photon, you can keep it as it is, plus work function is equal to work function plus kinetic energy, you can write 1 by 2 mv square also. This is also the way to write. Even you can write energy of a photon, h into f, is equal to this h into f naught is equal to 1 by 2 mv square. This is also how we write it. That's great. Now take a look at this particular question, boys and girls. For a certain metal, frequency F is 5 times F naught threshold frequency. Okay? Okay? Yes. Threshold frequency. And the maximum velocity of the coming electron is 8 in 10 raised power 6. See guys, what does the question say? You have a metal surface. On this metal surface, a photon is falling having the frequency 5 times the threshold frequency. This is a photon falling. It is having the frequency 5 times threshold frequency. So because of this, my dear NEET aspirants, an electron is coming out. Okay. So it says velocity of this electron V1, that is given as 8 into 10 raised power 6 meter per second. Okay. Then it says that the maximum velocity of the photoelectron, if V is equal to this, if frequency is equal to 2 times of F naught, it is nu. Here we write it. It says that when you send a photon which is having the frequency F is equal to 2 times of F naught. So due to this also electron will come out. What will be the velocity of this electron? It is saying. This is the question. Now guys, tell me one thing. Which of the formulas you are going to use in this particular case? You have got frequency, you have got velocity. Sir, as far as my logic is concerned, I can say I will be using this particular equation. Why? Frequency, and this velocity. So I can say in this particular case, so I'll be using in case 1. Case 1 means this case. Which equation I'm going to use? Sir, h into f is equal to h into f naught plus 1 by 2 mv square. Okay, v1 square. Means in this case where this photon is falling, electron is coming out, h is h, f. What is the frequency of the photon that is given over here? 5 times of f naught. So I can write 5 times of h is already there, f naught is equal to, and guys, if you take this over here, it will become minus hf naught, and it will remain 1 by 2 mv square. So 5 hf naught minus hf naught, it will be how much? 4 hf is equal to 1 by 2 mv1 v1 square. Now guys, in this particular case, what I can say, call this equation first. Now apply the same equation in case 2. Case 2. Take a look. This is the case 2. So here I can say, guys, hf. What is the value of f over here? 2 times of f naught. So it is 2 times of hf naught minus this hf naught. Hf naught is equal to 1 by 2 m v2 square, because velocity of the electron in this case is v2. Now 2 hf naught minus hf naught, it is going to be hf naught is equal to 1 by 2 mv2 square. This is the equation second. This is the equation first. Now divide first and second. Divide first and second. Divide this first and second. So it will be like, sir, 4 hf naught divided by hf naught is equal to 4 hf naught divided by hf naught is equal to 1 by 2 mv1 square divided by 1 by 2 mv2 square. Now boys and girls, this 1 by 2m, 1 by 2m, hf naught. So we can say v1 divided by v2 is equal to, I can say, a root of 4. Because of this square, it will be root 4. Root 4 is how much? 2. Now take this v2 over here. So v2 will come out to be v1 divided by 2. What is the value of v1? v1 is how much? 8 into 10 raised power 6 divided by 2. 2 ones are 2 4s are. So value of v2 is 4 into 10 raised power 6 meter per second. Is this clear? Is this clear? Is this clear, boys and girls? That's great. Now you have got a similar question on this pattern. 2 radiations of photon energy is 1 electron volt and 2.5 electron volt. Okay. You have got 2 radiation of photon energies, means photons are falling. This photon have got the energy of 1 electron volt. There is another photon, it has got the energy of 2.5 electron volt. Successively fall on a photosensitive metallic surface of work function 0.5. Work function of this metal surface is 0.5 electron volts. The ratio of maximum speeds emitted by the electrons. It says that electron will come out of this. It has speed v1. Electron will come out of this. It has speed v2. You guys are supposed to tell me what is the value of v1 divided by v2. That is the question. Again, my dear NEET aspirants, I can say energy is given, velocity is given. So which of the equations I can use? Sir, my logic says that I'll be using this. Because work function is also given, energy is also given, velocity you have to calculate. So I can use in this particular case, guys, I'll write over here, use energy of a photon is equal to work function plus 1 by 2 mv square. Now in case 1 and case 2, I'll be using these 2 equations. So can I say case 1? What is the energy of a photon in case 1? 1 electron volt is equal to. What is work function in here? That is 0.5 electron volt plus 1 by 2 mv1 square. 1 minus 0.5, that is 0.5, so it is going to be 1 by 2 electron volt is equal to 1 by 2 mv1 square. Then if I apply in case 2, guys, what will I say? In case 2, how much is the energy? 2.5 is equal to, what is work function? Work function is same, 0.5 electron volts plus 1 by 2 mv2 square. So 2.5 minus 0.5, so 2 electron volt is 1 by 2 mv2 square. This is equation second. This is equation first. Divide first and second. Divide first and second. When you divide first and second, so this is going to be 1 divided by 2 divided by this 2 into this 2 electron volt is equal to this 1 by 2 mv1 square divided by this 1 by 2 mv2 square. Now boys and girls, what can I say? 1 by 2m, 1 by 2m cancel. So EV cancels. 1 by 4. 1 divided by 4 is equal to V1 divided by V2 whole square. Take the square over here, it will become root. So 1 by root of 1 by 4, that is 1 by 2. So V1 divided by V2 came out to be 1 by 2. Guys, tell me, is this clear? Is this clear? Come on, quick. Okay. Sorry. Now see, what I'm trying to say is that, guys, energy of photon is h into f. If frequency increases, you say, sir, energy of photon increase, because directly proportional. Okay. Am I audible now? Now see, check. Okay, take a look. My dear NEET aspirants, if frequency increases, energy of photon increases. Okay. Now energy of photon is further equal to 5 plus kinetic energy maximum. If energy of photon increases, kinetic energy maximum also increases. Oh. Now guys, if kinetic energy increases, listen carefully. Guys, we say as kinetic energy, I recently told you, is EV naught. What is V naught? Stopping potential. So if kinetic energy increases, so I can say stopping potential V naught also increases. So basically, if frequency increases, energy of photon increases. If energy of photon increases, kinetic energy increases. If kinetic energy increases, we say stopping potential increase. So I can directly say this stopping potential has got the relation with frequency. So if frequency is large, you can directly say stopping potential would be large. Next, take a look, my dear NEET aspirants. Intensity. We say intensity I is equal to NHF divided by A into T. This is the formula of intensity. Can I say this intensity is directly proportional to number of photons? If number of photons increase, my dear NEET aspirants, I would say intensity increase. Or if intensity increase means number of photons increase. If more number of photons are falling onto the photosensitive metallic surface, so more electrons will be ejected. So more number of electrons will come out of the metal surface. So if I say number of photons increase, we say number of electrons will increase. And if number of electrons moving are increasing, we say photocurrent will increase, because photocurrent is directly proportional to the number of photons. So can I say, my dear NEET aspirants, in this case, this photocurrent has a relation with intensity. Photocurrent has relation with what? Intensity. If intensity is large, photocurrent would be large. Yes, sir. Now let's try to make this, let's understand this from a graph. You have got 3 graphs over here. You have performed 3 photoelectric effect experiments. This is the graph. Clearly, I can say the photocurrent of 3 equations is same. Photocurrent of 3 graphs is same. So if photocurrent is same, what does that mean? Intensity of 3 graphs is same. So my dear NEET aspirants, in this particular case, I would say photocurrent is same. It means intensity of 3 graphs is same. And if stopping potential of 3 graphs is different, it means if V naught is different, so it means frequency is different. Like V3 is greater than V2 is greater than V1. So frequency of 3, F3 is greater than F2 is greater than F. Next, take a look at this graph. In this particular case, stopping potential is same. If stopping potential is same, if V naught is same, what does that mean? Frequency of the 2 graphs is same. And my dear NEET aspirants over here, you can say intensity is different. What does that mean? If intensity is different, that means here photocurrent is different. Photocurrent is different, intensity is different. That means intensity is different. I hope these 2 graphs are crystal and clear. Tell me guys in the chats, is this clear? Then we will move on to the next one. Quick, tell me. Smash the like button if you're not like the session yet. Come on. Now, de Broglie's wavelength. Guys, see. De Broglie's wavelength. Take a look. de Broglie's wavelength. I want you guys to focus exactly over here. De Broglie's wavelength. Listen, guys, carefully. De Broglie said everything in this universe is a particle, is a wave, is a form of energy. De Broglie said, let me tell you like this. De Broglie said everything in this universe is a form of energy. This is energy. This is energy. Everything is energy, which sometimes behave like a particle, which sometimes behave like a wave. Or you can understand it like this. De Broglie said everything in this universe behaves like a wave. Like this box, sir, I can say this is a particle. How can I say this wave? De Broglie said this is a wave. This is particle as well as wave. We can feel its particle nature. And my dear NEET aspirants, when it comes to its wavelength, let's suppose there is a mass. It's mass m. It is moving with velocity v. What is the wavelength of this particle? That is lambda is equal to h divided by mv. This is what we call the de Broglie's wavelength. This is what we call the de Broglie's wavelength in this particular case. Okay. This is what we call the de Broglie's wavelength in this particular case. If an object is moving with certain velocity, it has mass. How much will be its wavelength? H divided by mv. Directly remember. Sir, this particle, can this behave like a wave? Yes. Will it have a wavelength? Yes. How much? H divided by mv. Now guys, listen carefully. This mv is what we call momentum. You can say h divided by p also. P is momentum. This is the de Broglie's wavelength in terms of momentum. Now, if I say de Broglie's wavelength, listen guys, de Broglie's wavelength in terms of kinetic energy. So you can say de Broglie's wavelength in terms of kinetic energy, this h upon 2m, m is mass, k is kinetic energy. De Broglie's wavelength for a relativistic particle, that particle which is moving with a large speed, huge speed, whose speed is comparable to the speed of light. Like speed of that particle is comparable to the speed of light. Like you have electron, proton, okay, these are relativistic particles. So de Broglie's wavelength for relativistic particles is under root of 1 minus v square by c square divided by m naught into v. V is the speed of that particle. C is the speed of light. M naught is the rest mass of that particle. And h is Planck's constant. H is Planck's constant. Then, my dear NEET aspirants, charge accelerated with potential difference delta V. If there is a charged particle which is accelerated with potential difference delta V, it would have de Broglie's wavelength lambda is equal to h upon under root of 2mq delta V. H upon under root of 2mq delta V. Okay, yes. Charge at rest in electric field. If there is a charged particle which is at rest in electric field, its de Broglie's wavelength will be h upon qet. Okay, then this charge will start moving. Charge placed in the electric field, external electric field, like this is the external electric field. In this you have charge placed. So what will be its de Broglie's wavelength? That is h upon qet. Q is the charge, E is the electric field, T is time. Charged particle and magnetic field. If you place a charged particle in magnetic field, its de Broglie's wavelength will be h upon qbr. Q is the charge, B is the magnetic field, R is the radius. Because radius of what? See, when the charged particle moves into the magnetic field, it moves in a circular path. So it has radius R. Radius of that circular path is R. For a gaseous molecule at temperature T, h upon 3 mkBT, where m is mass, kb is the Boltzmann's constant, T is the temperature. For an electron, revolving in nth orbit. Like guys, this is the nucleus. If I say this is the nth orbit, in this nth orbit electron is revolving, its de Broglie wavelength will be NH. N means which orbit? If I say fourth orbit, so value of N is 4. If I say third orbit, value of N is 3. NH upon under root of 2m into 13.6. This is the de Broglie wavelength of a charged particle of an electron revolving in nth orbit. Take a look, first question. JEE 2021 means the following particles have got same kinetic energy. Which particle? Alpha particle, proton, neutron, electron. Guys, see. Always remember, mass of alpha particle is greater than mass of neutron, is greater than mass of proton, is greater than mass of electron. This is the order. Now it says all these charged particles have same kinetic energy. Which one has largest wavelength? Guys, see, when it comes to the wavelength, it is h upon under root of 2m into ke, kinetic energy. This de Broglie wavelength in terms of kinetic energy. Since kinetic energy is constant, this is constant. So h is constant. So can I say this de Broglie wavelength is inversely proportional to root of mass? This is inversely proportional to root of mass. So what does that mean? The one which has large mass will be having less de Broglie wavelength. So de Broglie wavelength of this will be less. So for electron it will be large. De Broglie wavelength for electron is greater than for proton, is greater than for neutron, is greater than for alpha particle. So which one has largest? Largest will be for electron. This question. The ratio of velocity of proton and alpha particle. If the de Broglie wavelength of both the particles is same, you have alpha particle, you have proton. It says de Broglie wavelength of alpha particle is de Broglie wavelength of proton. You have to find the velocity ratio. Take a look. When it comes to the proton, when it comes to the alpha particle, if the mass of proton is m, mass of alpha particle is 4 times mass of proton. You can directly remember. So how do you write this? H divided by mass into velocity is equal to h divided by mass into velocity. Mass of this is 4m and this is velocity. This is velocity of, okay, this is for alpha. Wait. H divided by mass. Mass is 4m into velocity. Velocity is velocity of alpha. H divided by mv. Mass of this is m. Velocity is v. Velocity of proton. H will cancel. M will cancel. You have to find the ratio of velocity of proton. Take it over there. So velocity of proton divided by velocity of alpha is equal to, take it over there, 4:1. 4:1. This question, very good question on this de Broglie wavelength. Take a look, my dear NEET aspirants. What does the question say? Take a look, boys and girls. Listen carefully. An electron of mass m and a proton and a photon have same energy E. You have an electron. You have a photon and an electron. Okay. You have an electron and you have a photon. They have got same energy E. Could you please tell me what is the value of this energy? Guys, listen carefully. Lambda is equal to h upon under root of 2m into kinetic energy. Instead of kinetic energy, we write E. And how do you write energy of a photon? Energy of a photon is hc by lambda. Take this lambda over here. So this lambda of a photon will be hc divided by E. They have got same energy. This is lambda of electron, this is lambda of photon. Okay. The ratio of de Broglie's wavelength associated with the electron and the de Broglie's wavelength of photon. We have to find de Broglie's wavelength of electron divided by de Broglie's wavelength of photon. Now tell me, how can you write h divided by under root of 2m into E divided by hc divided by E? Yes. Now what can you cancel over here? Sir, my logic says this and this you can cancel. So you can write it like this, 1 divided by under root of 2m into E. And if you take this in the numerator, it will become E divided by C. So how can you write this further? Guys, see. You can write 1 divided by C. Then you have E upon under root of 2m into E. Multiply with root E and divide with root E. When you multiply and divide with root E into root E is E. So that E will be cancelled with this E. Now what will be the answer? 1 by C under root of E and this 2m. Both are in root. So you can say E divided by 2m. You can write it like this, 1 divided by C. Value of root is 1 by 2. So it will become E divided by 2m whole raised power 1 by 2. E divided by 2m. 1 by C, E divided by 2m whole raised power 1 by 2. We are done with first chapter. Let's move on to the second chapter, that is atoms and nuclei. Is this clear? Tell me quickly in the chats, everybody out there. Quick. Oh, I won't give you the break. Wait. Atoms. Now, boys and girls, let's start the chapter atoms. What do we have to study in the atoms? Guys, everything in this universe is made up of atoms, small tiny particles called atoms. How does this atom actually look like? Bohr said this atom looks like something like this. Guys, see, Bohr's atomic model. He said nucleus is present at the center of the atom and electrons are revolving around the nucleus. Nucleus is present at the center of the atom. This is nucleus. Okay. And around the nucleus, we say electrons are revolving. This is how an atom actually looks like. Okay. Yes. We have to study now this. An electron revolves in this orbit. Now, guys, listen carefully. First and the foremost thing, my dear NEET aspirants, if I say this is the nth orbit, if I say this is the first orbit means if electron is revolving here, means value of n would be 1. If I say this is the second orbit, value of n is 2. If I say third orbit, value of n is 3. Take a look. My dear NEET aspirants, what I want you to understand in this particular case is, that is, you will directly be moving to the mathematical analysis of Bohr's model. See, let's suppose there is an atom. This is the nucleus. This nucleus means it has charge Ze. Z means atomic number. What does Z mean? Z means atomic number. Atomic number. Okay, like for hydrogen it is 1, for helium it is 2, for lithium it is 3. And there is an electron which is revolving around this nucleus in nth orbit. Nth orbit. I am asking you what is the velocity of electron in the nth orbit. You please directly remember velocity of the electron in the nth orbit would be 2.2 into 10 raised power 6 Z by n. This we can write also V naught Z by n. Z means atomic number. Like in hydrogen, atomic number is 1. N means which orbit. This is the velocity of an electron in nth orbit. Now if I say, what is the relation between V and Z? Direct. What is the relation between V and N? Inverse. So what will be the graph? Graph between velocity and N. It would be inverse because V is inversely proportional to N. And V is directly proportional to Z. So between V and Z, graph would be the straight line. Graph would be the straight line. Next, radius of an electron in nth orbit. Let's suppose this is an atom. This is the center of the atom, nucleus. So from here to here, this radius is R. How much will be this radius? So directly remember, radius of an electron in nth orbit is 0.53 angstrom, n square by Z. So R is equal to R naught, n square by Z. What is the relation between R and N? R is proportional to n square. R is inversely proportional to Z. So if I say, guys, what is the relation between R and Z? R and Z is R inverse relation. This would be the graph. What is the relation between R and N? You can say, guys, R is proportional to n square. When this is the relation, graph would be upward parabola. And R and n square, guys, if you put R here, n square here, then we will be considering power of this as 1, so it will be straight line. But if you consider, guys, R and N, this R and N here, then upward parabola. But if you put directly n square, its power becomes 1, so graph would be linear. Directly remember these graphs. Now, April J means 2025. Now see the question. Assuming validity of Bohr's atomic model for hydrogen atom. For hydrogen atom, could you please tell me what is the atomic number 1? The radius of, okay, it is not, okay, for hydrogen like ions, oh, sorry. The radius of Li2 positive, guys, when I say Li2 positive, what is the atomic number 3? In its ground state, it says, what is the radius of Li2 positive? What is the radius of electron in Li2 positive in its ground state? Ground state means n is equal to 1. How do you find the radius? Radius is equal to R is R naught n square by Z. So R is equal to, it has mentioned from there only, this 1 by x into A naught. Instead of R naught, it has taken A naught. They have taken A naught. N square, what is the value of N? It says ground state is 1, so 1 square divided by Z is 3. So it will be 1 by 3 into A naught. It says what is the value of X, this X. What is the value of X? X is 3. Same question. Find the maximum angular speed of an electron of a hydrogen atom in stationary orbit. For hydrogen atom, Z is 1. Stationary orbit means first orbit, N is 1. It says what is the angular speed? Angular speed means omega. Angular speed means omega. You have to tell me angular speed. Just a second. You have to tell me the angular speed, guys. Take a look. So we say V is equal to R omega. this is the relation we know. So from here, omega will be V by R. Now, if you have to, you know V, how do you find V? V naught Z by N upon, what is R? R naught N square by Z. V naught is 2.2 into 10 raised power 6. Z. Z is 1, N is 1. So it will be 1 by 1 upon R naught. R naught is 0.53 angst 1. So 0.53 into 10 raised power minus 10. So 1 by 1. Because 1 square by 1. Now omega will come out to be 10 raised power minus 10 when it goes in the numerator. 10 raised power plus 10. 2.2 upon 0.53 into 10 raised power 16. Now solve this from your end and check the exact answer. Is this clear? Is this clear? Smash the like button, guys. Come on. Do it quick. Then comes, my dear NEET aspirants, time period of revolution of an electron in nth orbit. Time period of revolution of electron means how much time this electron is going to take in completing one cycle. In one complete cycle, how much time it is going to take. Okay. Guys, directly remember. Time period of an electron in nth orbit is 1.51 into 10 raised power minus 16. We say n cube divided by z square. How much time it is going to take in one cycle? This will be the time period. Even you can say frequency. Frequency is inverse of time period. Inverse of time period. 1 upon time period. Okay. Just do the inverse of this. Can I write that will be 1 upon, guys, 1.5 you can say 3 by 2 into 10 raised power minus 16 n cube divided by z square. Frequency means number of cycles per second. How many number of cycles it is going to do every second. Now take this in the numerator. You can write 2 divided by 3 into 10 raised power plus 16. When this goes in the numerator, and this also, it becomes z square by n cube. This will be the frequency. Okay. Yes. Now guys, take a look. Energy of an electron in the nth orbit. Let's first write energy. Energy of an electron in nth orbit. Energy of an electron in the nth orbit. Now guys, take a look. Let's suppose I say this is the nucleus. Around the nucleus, electron is revolving. This is having the charge E. The radius is R. It is moving with the velocity V. Guys, since the charge is in motion, it has mass, so it has kinetic energy. So first of all, I'll be writing the kinetic energy. My dear NEET aspirants, when I say the kinetic energy of this electron in the nth orbit, listen to me very carefully. You'll be directly writing that is Z E square upon 8 pi epsilon naught R. Now, when you have two charges placed at certain distance, they have potential energy also. So potential energy is going to be minus ZE square upon 4 pi epsilon naught R. 4 pi epsilon naught R. When I say total energy would be negative of this minus ZE square upon 8 pi epsilon naught R. This would be the total energy. Total energy is kinetic energy plus potential energy. Okay. Absolutely, I can say in this particular case, my dear NEET aspirants. Okay. Yes. So, guys, can I write it like this? This total energy, I can say, this total energy would be, if I say, let's take the magnitude, ZE square upon this is this is 8. So to something like this, ZE square upon 4 pi epsilon r. ZE square upon 4 pi epsilon naught r. This is potential energy. So this total energy magnitude will come out to be potential energy magnitude divided by 2. Even it is equal to the kinetic energy of magnitude also. Okay. Now, if I make the graph, guys, see, kinetic energy is inversely proportional to R, but it is positive. Kinetic potential energy is inversely proportional to R, but it is negative. Total energy is inversely proportional to R, but it is negative. So graph would be like this. This one, energy versus R. Kinetic energy is positive from the upper side. Total energy and potential energy is negative. That's why from the lower side. Kinetic energy would be positive. Okay. Yes. Now, guys, one more important thing I just want to say. We say total energy is minus ZE square upon 8 pi epsilon naught R. Take a look. What is the value of R? R naught n square by Z. Put it here. Total energy would be minus E square minus ZE square upon 8 pi epsilon naught. Instead of this R, I can write R naught n square by Z. Now take this in the numerator. It will be minus E square upon 8 pi epsilon naught R naught. This Z into Z becomes Z square divided by n square. This is total energy. Now, guys, value of this comes out to be 13.6. When you put the value of E, pi, epsilon naught, R naught. So this total energy becomes minus 13.6. Then you have Z square by n square. Even kinetic energy would be this also. Because kinetic energy and total energy are same. But kinetic energy is positive plus 13.6 Z square by n square. So this is Z is atomic number, n is with orbit number. Okay. If I say for hydrogen atom, guys, what is Z? Z is 1. If you put Z1 over here, so total energy for hydrogen will be minus 13.6 divided by n square. Is this clear? Clearo? Now take a look, guys. This is important. For a hydrogen atom, how do you find total energy, guys? I recently told you, for a hydrogen atom, total energy is minus 13.6 divided by n square. Now, if I say we are talking about the first orbit, so means n is equal to 1. Put n is equal to 1. So in the first orbit, or you also call it the ground state. First orbit or ground state, n is equal to 1. So put 1 here, so it will be 13.6, minus 13.6. So the energy of an electron in the first orbit of hydrogen atom is minus 13.6. If we talk about second orbit, means n is equal to 2. That means first excited state. In first excited state, energy would be, so put over here 2 square. 2 square is 4. 13.6 by 4 will be minus 3.4. Then in third orbit or second excited state, energy of electron is minus 1.51. Then 0.85. Okay, and so on. Now see the question. There's a question of J Mains 2025. J Mains 2025. I would want you guys to focus exactly on this particular question and tell me what is going to be the answer over here. Considering Bohr's atomic model valid in this particular case, my dear NEET aspirants, okay, the energy of hydrogen atom in ground state. If I say you have hydrogen atom and you have ground state means for hydrogen atom Z is 1, ground state means N is 1. What is the energy of an electron? What is the total energy? Oh, that is minus 13.6. Recently you saw. It says the energy of hydrogen atom in the ground state is same as the helium He positive ion in the first excited state. Guys, if we talk about helium He positive, we say for helium Z is 2. And it says if the electron is in the first excited state of helium means N is also 2. First excited state means second orbit. What will be the total energy, guys? That is minus 13.6 Z square by N square. Put Z2 minus 13.6. So Z is 2. 2 square divided by 2 square. This and this will be cancelled. So minus 13.6 electron. Oh, means the energy of an electron in the ground state of hydrogen atom is same as energy of an electron in the first excited state of helium. So option A is correcto, correcto. Are you clear with this guy? Tell me. Okay. Even when you check for this also, my dear NEET aspirants, option B, the energy of hydrogen atom in ground state, that means 13.6, is same as that for Li positive ion in second excited state. Guys, Li2 positive. What is the atomic number? 3. And it says second excited state. Second excited state means N is equal to 3. You check here. Second excited state means N is equal to 3. What is the energy? Total energy? Minus 13.6 Z square by N square. That is 3 square divided by 3 square. This and this 13.6. So this is also correct, guys. This is incorrect. You can check it from your end. This is incorrect. A and B only is the correct. A and B only is the correct. Okay, this is the previous year question of NEET. What does it say? The total energy of an electron in an orbit is minus 3.4. Total energy is minus 3.4. It's kinetic and potential energy are, guys. Kinetic energy and total energy are same, but this is negative and this is positive, plus 3.4 electron. Now you have to tell me potential energy. But tell me one thing, my dear NEET aspirants. When I say total energy, okay, it is, I can simply say it is negative of potential energy divided by 2. Yes or no? Now tell me in this particular case, my dear NEET aspirants, because I have told you over here. I've told you over here. Okay, in this particular case, total energy is potential energy divided by 2. So potential energy will be taken over there. So potential energy will be minus 2 times of total energy. So minus 2 times of total energy is how much? 3.4. So 3.4. So that is minus 6.8. So potential energy is minus 6.8. Total energy is, kinetic energy is plus 3.4. Option C. Now this question. Guys, is this clear till over here? Smash the like button if you're not like the session yet. The electron in the hydrogen atom jumps from excited state n is equal to 3 to its ground state n is equal to 1. See guys, it says an electron in that excited state n is equal to 3. N is equal to 3 to n is equal to 1. One more important point I will be mentioning over here. When an electron jumps from higher excited state to lower excited state, in this case, a photon is released. Okay. In this case, a photon is released. This is a photon. And this photon has an energy of, listen carefully, that is energy gap between the two orbits. When electron makes the transition from higher orbit to lower orbit, and a photon is released, my dear NEET aspirants. 2 points I will be mentioning over here. This is even Bohr's third postulate. Guys, when electron, guys, let's suppose this is the nucleus. This is the first orbit. This is the second orbit. This is the third orbit. If you want an electron to make the transition from lower orbit to higher orbit, then you have to supply the energy to the electron in the form of photon. So means you will be sending a photon over here. So this photon will go, it will strike, and it will give energy to the electron. So energy has to be supplied. And boys and girls, when an electron makes the transition from higher orbit to lower orbit, here energy is released in the form of photon. Here photon is supplied, means energy is supplied. Here photon is released or energy is released. These are the two statements. Now take a look here. If the electron makes transition from here to here, a photon is released. What is the energy of this photon? Energy of this photon would be energy gap between the two. That means energy of the electron in this orbit minus energy of an electron in this orbit. What is the energy of an electron in the third orbit? Energy of an electron in the third orbit is minus 1.51. In the first orbit, minus 13.6. So it would be minus 1.51 higher orbit energy minus lower orbit energy minus to 13.6. So this would be That is 12.1. 1 electron volts. Now guys, further it says, and thus photon emitted falls on a photosensitive metallic surface. This photon further falls on the photosensitive metallic surface. Sure. Which has a work function of 5.1 electron volts. Okay. Now, when photon falls on the photosensitive metallic surface, electron is ejected, photoelectric effect will take place. You have to tell me stopping potential will be, what will be the value of phi? Stopping potential, sorry. What will be the value of stopping potential? V naught. Because when the photon falls on a photosensitive metallic surface, so photoelectric effect will take place. You know, sir, in photoelectric effect, energy of photon is work function plus kinetic energy maximum. Okay, kinetic energy maximum will be EV naught. Now tell me, energy of photon is how much? 12.1 is equal to, work function is how much? 5.1. EV plus EV naught. So 12.1 electron volt minus 5.1 electron volt, that is 7 electron volt, is equal to EV naught. E and E will be cancelled. So V naught means stopping potential is 7 volts. Is this clear? Or tell me in the chats, everybody. Tell me quick. Let's move on to the spectrum. Guys, smash the like button if you're not like the session. Come on, do it quick. Because liking the session is marking the attendance. Spectrum. This is important, by the way. Now, boys and girls, I want you to understand this very carefully. Spectrum. We say it is the collection of radiations of different wavelengths on a photographic plate. My dear NEET aspirants, let's suppose you have got a white light over here. You have got a white light over here. And this white light basically passes through prism. You might have seen the prism. When white light passes through the prism, it splits into 7 different colors. VIBGYOR. Violet, indigo, blue, green, yellow, orange, red. And further you have placed a screen over here. When these lights fall onto this photographic plate or the screen, it forms a pattern over here. Red color line, orange, yellow, green. So this collection of these radiations on this photographic plate, this is what we call the spectrum. Formation of these lines, formation of these spots on the screen is what we call the spectrum. It is the image produced on the photographic plate. And these spots will have different wavelengths. Now, guys, you have 2 types of spectrum. First is absorption spectrum and then you have emission spectrum. Listen carefully. Let's suppose you have an atom over here. An electron is revolving in the first orbit of that. You want this electron to make the transition from first orbit to the second orbit. What will you do? You will give the energy. You will send a photon. How much energy should the photon have? Sir, the energy, if you want to make the transition from here to here, energy of a photon must be equal to the energy gap. That means this energy minus this energy. This is 3.4, this is 13.6. So that will be 10.2. So energy of a photon must be equals to 10.2. So if you give the photon to this electron, if you send a photon of energy 10.2 electron volts, this electron will make the transition from first to second. Yes, sir. So this makes when you send a photon, this electron eats up the photon. It makes the transition from first orbit to the second orbit. Listen carefully. And a screen is present over here. A dark spot is present on the screen, is created on the screen. A dark spot is created on this bright screen. Why is this dark spot created? Creation of this dark spot is what we call the absorption spectrum. This tells us that an electron has made the transition from lower orbit to higher orbit. Means it has eaten up the electron. It has eaten up the photon. It has eaten up the entire energy. That's why the dark spot was created. Creation of this dark spot on the bright screen. This is called absorption spectrum. How do you define absorption spectrum? If an electron makes the transition from lower orbit to the higher orbit, we say a dark spot is created on the spectrum. Creation of this dark spot means electron has eaten up the energy so that it can make the transition from lower orbit to the higher orbit. Then you have emission spectrum. Take a look. This is important. When an electron makes the transition from higher orbit to lower orbit, a photon is released. We know energy is released in the form of a photon, and that photon further falls onto the screen, a dark screen. When a photon falls onto the dark screen, it creates a bright spot. Now, if the wavelength of this photon matches with the wavelength of red color, it is going to create red spot. If the wavelength of this photon matches with the wavelength of orange, it is going to create orange spot. If the wavelength of this photon matches with the wavelength of yellow, it is going to create the yellow spot. So this is what we call emission spectrum. Emission spectrum means when an electron makes the transition from higher orbit to the lower orbit, thus photon is emitted, photon is released, which falls onto the dark screen, creates a bright spot or bright line. This creation of bright line on the dark background, this is what we call the emission spectrum. Oh, tell me, is this clear? Now guys, take a look. This emission spectrum, which I have explained over here, this is the real life situation. You can understand this normally, properly. I can tell you in this particular case, my dear NEET aspirants, this emission spectrum, we show it in the spectral series also. We define this emission spectrum in spectral series also. How? Let me make you understand. We say, my dear NEET aspirants, when electron makes the transition from higher orbits to the lower orbits, this we can show in the spectral series. First spectral series is Lyman series. Let me show you. We say these. Okay, first of all, in the spectral series, my dear NEET aspirants, in the spectral series, we represent orbits. Please listen. We represent orbits with the help of straight lines. This is the first orbit, means n is equal to 1. This is ground state. This is the second orbit, n is equal to 2. This is third orbit, n is equal to 3, fourth or fifth, up to infinity. Okay? Yes. Now, my dear NEET aspirants, what I'm trying to say is that if an electron makes the transition from second orbit to the first orbit, we know, sir, in emission spectrum, from second to first, it will photon is released, which falls onto the screen. It will create a bright line. So that bright line in spectral series I'm showing over here, this. What does this say? It shows us an electron has made the transition from n is equal to n is equal to 1. That's why this line was created. In reality, this line was created on the spectrum. If an electron makes the transition from third to second, this line is created. Third to first, third to first. If an electron makes the transition from fourth to first, this line is created. Fifth to first, infinity to first, this is the last line. Now, in the Lyman series, you only show those transitions in which electron moves from higher orbit to first orbit. That's it. That's it. So we say, here we show only those transitions where electron moves from higher orbit to first orbit. Means final orbit is 1. Finally, it has to come to 1. Initial can be, and initial can be 2, 3, or up to infinity. One more important thing, my dear NEET aspirants. This is what we call the first line of Lyman series. First line. First line. This is what we call the last line. Last line. My dear NEET aspirants, listen very carefully. If I say how much is the energy of this first line, guys, logically, first line is created when electron moves from here to here. How much is this energy? How much photon will release? What will be the energy of the photon or first line? Energy of the photon will be 10.2. Now, how much is this energy gap? 12.1. How much is this energy gap? 10.2. So, if electron moves from second to first, a photon is released which has energy 10.2. If electron makes the transition from third to first, photon is released which has the energy 12.1. So, this is the large energy, this is the less energy. So, first line will have less energy, minimum energy. This will have maximum energy. And we say energy is directly proportional to the frequency. So minimum frequency, maximum frequency. And we say, guys, frequency is inversely proportional to wavelength. So maximum wavelength, minimum wavelength. This you need to remember. Balmer series. In Balmer series, we show the transitions when electron moves from third to second, okay, fourth to second, fifth to second, infinity to second. So here, final orbit is 2 and initial orbit can be 3, 4, 5, up to infinity. This can be the initial orbit. Okay, this first line, second line, third line, fourth line. Is that clear, boys and girls? Here also, first line will be having the maximum wavelength, minimum frequency, minimum energy. And last line will be having the minimum wavelength, maximum energy, maximum frequency. Then Paschen series or M series. In Paschen series, we say, fine, here we show only those transitions in which electron comes to the third orbit. From which orbit? 4, 5, 6, up to infinity. Okay, this is Paschen series. Now, my dear NEET aspirants, if somebody says that when an electron makes the transition from higher orbit to lower orbit, a line is formed on the spectrum, how much is the wavelength of this line, or you can also say photon. Guys, when electron makes the transition from higher orbit to the lower orbit, photon is released. So this photon created the line only, na? Whatever is the wavelength of the photon, same will be the wavelength of this line. So we say wavelength of the photon emitted. So you have to directly remember this. This is the wavelength of the photon emitted. 1 by lambda is equal to R. R means Rydberg constant. 1 by n final square minus 1 by n initial square. This is the final orbit, this is the initial orbit. So here, lambda means wavelength. And 1 by lambda means wave number. Now take a look. JEE 2025. The ratio of the shortest wavelength of Balmer series to the shortest wavelength of Lyman series. Guys, which one will have the shortest wavelength in Balmer series and Lyman series? First line has got maximum wavelength, shortest wavelength. Last line will have the shortest wavelength. So here also, last line will have the shortest wavelength. So last line of Balmer series, last line of Lyman series. So that's what it is saying. So it says last line of Balmer and last line of Lyman. Last line of Balmer and last line of Lyman. Now guys, tell me one thing. If we are talking about the last line of Balmer and last line of Lyman series, listen carefully, my dear NEET aspirants. Last line means in which n initial is infinity. And Balmer series, n final is, I would say, 2. Because when an electron makes the transition from infinity to 2. And last line of Lyman means when n initial is infinity, n final is 1. Finally, it is 1. Find wavelength here. 1 divided by lambda Balmer is equal to Rydberg constant up into 1 by n final square. 1 by lambda is equal to R, 1 by n final square minus 1 by n initial square. 1 by n final square is 2 square. 2 square is 4 minus 1 by n initial square, that is infinity. 1 by infinity is 0. So 1 divided by lambda Balmer is equal to R by 4. Do the reciprocal, lambda Balmer is equal to 4 by R. Now if you check here, 1 divided by lambda Lyman is equal to R, Rydberg constant. 1 by n final square, that is 1 by 1 minus 1 by infinity. So 1 by lambda Lyman will come out to be R. Do the reciprocal, lambda Lyman will be 1 divided by R. Now if I say lambda Balmer divided by lambda Lyman. Lambda Balmer is 4 by R. Lambda Lyman is 1 by R. This and this will be cancelled. So 4 is to 1. Can you tell me the answer of this JEE 2025? Come on, tell me. For a hydrogen atom, the ratio of the largest wavelength of Lyman series, largest wavelength. Largest wavelength means first line. First line of Lyman to that of Balmer means first line of Balmer. What will be the n final over here? 1. What will be n initial over here? 2. When electron moves from 2 to 1, that will be the first line. Here, n in final, that is 2. N initial, that is 3. When electron moves from 3 to 2. So let's find 1 divided by lambda Lyman will be R. 1 divided by lambda Lyman will be R. 1 by n final square, that is 1 by 1 minus 1 by n initial square, 1 by 2 square. 1 divided by lambda Lyman would be R. Now guys, tell me in this particular case, 2 square is 4. I would directly write over here 4. 4 minus 1, that is 3 by 4. So 1 divided by lambda Lyman would be 4 by 3R. And final square minus 1 by n initial square. Okay. Wait. This would be 3R by 4. Do the reciprocal, lambda Lyman would be 4 by 3R. Okay, here 1 by lambda Balmer is equal to R. 1 by n final square, 1 by 4 minus 1 by initial square, 1 by 9. 3 square is 9. 1 by lambda Balmer would be R. 9 minus 4, that is 5, divided by 9 into 4, that is 36. So lambda Balmer will come out to be 36 divided by 5R. Now you can say lambda Lyman divided by lambda Balmer. Lambda Lyman is 4 divided by 3R divided by lambda Balmer, that is 36 by 5R. So when you multiply over here, it will be 5R divided by 36. R and R will be cancelled. 4 1s are, 4 9s are. So this will be 5 divided by 9 into 3 is 27. So 5 by 27. Option A. That's great. Let's move on to the chapter 3, that is nuclei. That's nuclei. Is this clear? Or tell me quick. Tell me. Okay. Now let's take a look. Let's take a look at this, my dear NEET aspirants. Okay. Now we have got the third chapter, that is what we call nuclei. I would want you guys to focus exactly over here in this particular case. Okay. Okay. Listen carefully. My dear NEET aspirants, when it comes to the chapter nuclei, listen guys very, very, very carefully. I want you guys to give me 100% attention. In the chapter nuclei, you have to talk about the nucleus. Like, let's suppose if I say, this is an atom. This is an atom. Okay. We say at the center of the atom, you have got nucleus. At the center of the atom, you have got nucleus. Okay. And around the nucleus, you have electrons revolving. If I, let's suppose, say what is present inside this nucleus, what is present inside this nucleus? What is present inside this nucleus here? You'll be saying inside this nucleus you have protons and neutrons. Inside this nucleus you have what? Protons and neutrons. So this is the nucleus. So you have to now study about this nucleus. Study about this nucleus. I believe this is clear over here. Now, my dear NEET aspirants, first and the foremost thing, when it comes to the nuclei, the particles present inside the nucleus are protons and neutrons, and the particles which are present inside the nucleus are called nucleons. These are called what? Nucleons. Or we say hydrons, or we say baryons. Okay? And one more important thing. Radius of the atom, we say it is 10 raised power minus 10 meters. And radius of nucleus, we say 10 raised power minus 15 meters. 10 raised power minus 15 meters. Okay, next. Representation of a nucleus. Listen carefully. How do we represent the nucleus, boys and girls? Let's suppose we have a nucleus, we gave it a name X. The name of the nucleus is X. We will mention at top of it A and at the bottom of it Z. Sir, what does this A and Z actually mean? A means the mass number. A means what? A means mass number. Mass number means number of protons plus number of neutrons. How many number of protons and neutrons are present in the nucleus? That is mass number. And this Z, my dear NEET aspirants, means atomic number. Z means what? Atomic number. Atomic number means number of protons. Like, let's suppose I give you an example over here. Let's suppose we have a nucleus. I'll write over here 20 and this is 10. Could you please tell me how many number of nucleons are inside this, sir? Mass number here is 20. Means number of protons plus neutrons. Atomic number is Z is 10. Means protons are 10. Could you please tell me what will be the number of neutrons? Number of neutrons will be A minus Z. That will be 10. 20 minus 10. So number of neutrons is basically what? A minus Z. That's great. One more important point which I want to tell you. Binding energy. This is important. Guys, listen carefully. Let's suppose you have got a nucleus over here. This is the nucleus. Mass number of this nucleus is A. Atomic number of this nucleus is Z. And what is the total mass of the nucleus? M. Now I want you to break the nucleus. Break it. Break it. In order to break the nucleus, you have to use the energy. Obviously, sir. I have to use the energy in order to break the nucleus. I'll have to use the energy to break this nucleus. When you break nucleus, you take the nucleons out. You take protons out. You take neutrons out. Yes, sir. Now, my dear NEET aspirants, Z number of protons are there. Could you please tell me how many will be the number of neutrons? A minus Z will be number of neutrons. So you took Z protons out. You took what? Z protons out. What will be the mass of Z protons? Z protons multiplied by mass of one proton. That is ZMP. What will be the mass of a proton? MP. What will be mass of two protons? 2 MP. What will be mass of three protons? 3 MP. What will be mass of Z protons? ZMP. Then, my dear NEET aspirants, A minus Z number of neutrons. So how much will be the mass of A minus Z number of neutrons? A minus Z into Mn. So this is mass of neutrons. So this will be the total mass of the neutrons. And this mass, ZMP, that is mass of protons, plus A minus Z Mn, mass of neutrons, it came out to be greater than M. M was the collective mass of nucleus when the protons and neutrons were inside the nucleus. When protons and neutrons were inside the nucleus, at that point of time, mass of this nucleus was M. And when you took those out, we say it came out to be greater than M. See what I'm trying to say? I want you to understand it here. Let's suppose this is a nucleus. It has got 5 nuclear protons, 5 neutrons. These have got 5 kg mass. These have got 5 kg mass. What is the total mass of this nucleus over here? 10 kg. When you took this out, when you took protons out, neutrons out, mass of protons came out to be 5.5. Mass of neutrons came out to be 5.5. So how much is that? That is 11. So that is greater than 10. Collective mass. That's what I'm trying to say. Why does it actually happen? Listen carefully. Why mass came out to be greater than the collective mass? Listen. The energy which is used in breaking the nucleus, the energy which is used in breaking the nucleus is stored in the form of a mass. This energy which you use to break the nucleus, that is stored in the form of mass. That is stored in the form of mass. That is stored in the form of mass of nucleons. And this energy is called a binding energy. This energy which is used to break the nucleus and then further is stored in the form of mass of nucleons, this is called the binding energy. This is called a binding energy. So binding energy is that energy which is used to break the nucleus and is stored in the form of mass of nucleons. That's why mass of the nucleons increase. Now we say due to this binding energy only mass defect occurred. Mass defect means, guys, how much is the final mass? 11. What is the initial mass? 10. How much it was supposed to be? 10. But it came out to be 11. What is the mass defect? 11 minus 10, that came out to be 10. So 10 is the mass defect that occurred over here. Sorry, 1. 11 minus 10 is 1. 1 is the mass defect that occurred over here. So if somebody say how much is the mass defect? That is final mass ZMP plus A minus ZMN minus initial mass, collective mass. This is the mass defect. Now if somebody says what is the value of binding energy? Directly remember, binding energy is mass defect into C square. Binding energy is mass defect delta M into, I would say, C square. Delta M into C square. Okay. And one more important thing. Binding energy per nucleon is proportional to stability. Binding energy per nucleon is proportional to stability. Let me make you understand this point. Wait. Okay. Now, my dear NEET aspirants, listen to me very carefully. What does this binding energy per nucleon actually mean? Okay, take a look. What does binding energy per nucleon actually mean? Let's suppose this is a nucleus over here. Listen to me very carefully. This is a nucleus over here. If I say this has got 1, 2, 3, 4 nucleons inside this nucleus. Okay. I want you guys to break this nucleus. You say, sir, that energy which is used to break the nucleus is called binding energy. This is, let's suppose, 10 electron volts. Okay. So this is called binding energy, which is used to break the nucleus. Total. If I say how much is the binding energy per nucleon, how much will be the binding energy to take out one nucleon from the nucleus? You will be say binding energy per nucleon. Nucleon means A, number of nucleons. So how many number of nucleons are there? 1, 2, 3, 4. So it will be 10 divided by 4. So this will be 2.5. So 2.5 is the amount of binding energy which is used to take one nucleon out of the nucleus. So if I say how much is the binding energy to take out all the nucleons, that is 10. How much is the binding energy to take one nucleon from the nucleus? That is 2.5. So this is binding energy per nucleon. And this binding energy per nucleon is proportional to stability. This binding energy per nucleon is proportional to stability. More is the binding energy per nucleon, more is the stability. Like, let me show you this. There is a graph between binding energy per nucleon versus mass number. Graph between binding energy per nucleon, that is stability, because this is stability only, na? Versus, I would say, mass number. Versus, I would say, mass. Now, guys, this graph came out to be something like this. This graph came out to be something like this. As you keep on increasing the mass number, this binding energy, this stability was increasing. After certain value, then again it keeps decreasing. Okay. Now let's suppose if there is a nucleus which has mass number A is equal to 10, it has this much of stability, less stability. If there is a mass number A is equal to 30, it has this strong stability. It is highly stable. Highly stable. Now guys, here we mention the value of A is equal to 30. Those nucleons which have mass number A is equal to 30, this much is the stability of those nucleons. And here it is 170. All those nucleons which lie between A is equal to 30 to A is equal to 170, they have got this much of binding energy per nucleon. Strong stability, strong stability. They're highly stable. The nucleus, the nuclei, which are having mass number less than 30, those are having this much stability, less stability. These are unstable nuclei. Even here also, stability again decreasing. Those nuclei which are having mass number greater than 170, those are also unstable. See guys, those nuclei with mass number less than 30 are lighter nuclei. These are called lighter nuclei. And these are unstable. Okay. And those nuclei with mass number greater than 170, these are heavy nuclei and these are also unstable, my dear NEET aspirants. Take a look, I'll make you understand this. Take a look, I'll make you understand this. Take a look, guys. Take a look. What I'm trying to say in this particular case is, this is mass number A is equal to 30. If there are nucleons which are having less than mass number A is equal to 30, that means these are unstable. Why? Because they have got less stability. Stability is on y-axis. And these are lighter nuclei. And these are heavier nuclei. Mass number greater than 170. These are heavier nuclei. These are also unstable. Now guys, see, this nucleus and this nucleus are unstable. Why? Because they have less number of nucleons. Let's suppose this has got 15. This has got, I would say, 15. So 15 is less. Now if they join together, 15 plus 15, it becomes 30. So they become this A is equal to 30. Now this becomes stable. So when two nuclei join together, fuse together to form a bigger nuclei, to attain stability, this process is called a fusion. This process is called a fusion. See? See, two lighter nuclei will combine to form a bigger nuclei in order to attain stability. And this process is called fusion. And energy is released in this process. Energy is released in the fusion process. Energy is released in the fusion process. Let's suppose mass number of this is 200. If it breaks into two smaller nuclei, 100 and 100. Now 100 lies in the range of 30 and 170, between 30 and 170. Now this becomes stable. 100 and 100 is stable. So when a bigger or heavy nuclei, breaks into two small nuclei to attain stability, when a heavy nuclei breaks into two small nuclei to attain stability, this process is called a fission. This process is called a fission. A bigger nuclei with A is greater than 170 breaks into two smaller nuclei to gain stability. And the process is called fusion. And energy is also released in the process. Whenever something attains stability, my dear NEET aspirants, we say energy is released in the process. Energy is released in the process. Okay, this was fission and fusion. Now, take a look at this, then afterwards I'll show you the questions. That is Q value of the reaction. Take a look. Let's suppose you have A nuclei plus B nuclei, two nuclei. They join together, fuse together, or this is what we call reactant nuclei. These two nuclei are converted to C plus D. This is called product nuclei. This is a kind of nuclear reaction. Like here, when these two nuclei join together to form a bigger nuclei, this is a nuclear reaction. Okay, same is the case here. When A and B nuclei are converted to C nuclei plus D nuclei, in this nuclear reaction, some energy may be either absorbed or some may be released. It depends upon stability. That is what we call Q. The energy which is either absorbed or released in the process. And this is called Q value of the reaction. In a nuclear reaction, some energy is absorbed or some energy is released. Okay. And that is called Q. That is the Q value of the reaction. And this Q value of the reaction, my dear NEET aspirants, how do we find it? Mass of reactants minus mass of products into C square. In terms of binding energy also you can calculate. Q value of the reaction will be, okay, it's in terms of mass. In terms of binding energy, you can say binding energy of products. This is binding energy of products. Okay. Binding energy of products minus binding C plus D. Binding energy of C plus binding energy of D. Binding energy of products minus binding energy of reactants. This is how do you find Q value of the reaction in terms of binding energy. So Q value of the reaction is the energy which is either absorbed or released in the nuclear reaction. And how do you find it? Binding energy of products minus binding energy of reactants. Take a look at this particular question, boys and girls. J means 2025. Energy released when two deuterons. Two deuterons means 1H2 plus 1H2. Fuse to form, they fuse to form a helium nucleus. Helium nucleus means 2He4. And in this nuclear reaction, some energy may be absorbed or released. Release, it says. Binding energy per nucleus. Okay. You have to tell me what is the value, Q value of the reaction here. How much is the energy released? Q value of the reaction. Now, guys, tell me one thing. Everybody of you, tell me one thing. We say Q value of the reaction is binding energy of products minus binding energy of reactants. So you say Q value of the reaction is binding energy of products. These are the products. What does it say? Binding energy per nucleon of 1H2 is 1.1. What does that mean? That means for this 1H2, how many number of nucleons are there? 2. How many number of nucleons are there? 2. 2 plus 2 is 4. So one nucleon has got how much binding energy? 1.1. So 4 nucleons will have got how much? 4 into 1.1. See, this is the product. In product, how many nucleons are there? 4. One nucleon, see, binding energy per nucleon of 2He4 means one nucleon of 2He4 has how much binding energy? 7. 4 will have how much? 4 into 7. So that will be 4 into, I would say 7. This binding energy of products minus binding energy of reactants. For reactants, one nucleon has 1.1 binding energy. 2 plus 2, 4. 4 into 1.1. This is the binding energy of reactants. So Q will be 28 minus, this is 4.4. Is this clear? Oh? Clear? Like you have this. The binding energy per nucleon of 3Li7 and 2He4 are 5.60 and 7.06 respectively. In the nuclear reaction, this is the nuclear reaction. 3Li7 plus 1H1, it is not 1He, 1H1. Then it gives 2He4, helium nucleus, plus 2He4 plus Q. You are supposed to find the value of Q. Guys, in this Q value of the reaction, what will you say? Binding energy of products minus binding energy of reactants. Now, in products, how many number of nucleons are there? 4 plus 4 is 8. If you see over here, binding energy of 2He4, binding energy per nucleon of 2He4 is 7.06. So one nucleon of 2He4 has how much binding energy? 7.06. So 4 plus 4, 8 will have how much? 8 into 7.06 minus binding energy of reactants. Reactant is 1H1. Guys, 1H1, if its mass number is 1, means it is only one particle. One particle will have 0 binding energy. Why? Because binding energy is that energy which separates two particles, which takes out particles out of the nucleus. If there is only one particle, how will you separate it? So for this, it will be 0. Now for 7, binding energy of 3Li7, binding energy per nucleon of 3Li7 is 5.60. One nucleon of this 3Li7, it has how much binding energy? 5.60. 7 will have how much? 7 into 5.60. Is this clear? It will be 17.6. Please check it from here. Something like this. 17.4. Is this clear? Is this clear? Is this clear? Chapter 4. Semiconductors. Semiconductors. Is this clear? Or tell me in the chats. We'll take the break at 1 o'clock. Now, boys and girls, when it comes to the chapter semiconductors, listen to me very carefully. There are 3 types of materials, boys and girls. The first one is conductors, You have insulators, and then you have semiconductors. Then you have semiconductors. Take a look. My dear NEET aspirants, we say here conduction is possible. Conduction is possible. Means current can flow here. Conduction is not possible. Conduction is not possible. Current cannot flow. Sir, can you convert this insulator into a conductor? No. Can you convert this to there? No. But the semiconductor has a property. It behaves like what? Conductor also, insulator also. So means its conductivity can be altered. If we increase the conductivity of a semiconductor, it becomes conductor. If we decrease the conductivity of a semiconductor, it becomes insulator. Its conductivity can be altered. If you increase the conductivity, sir, how can we increase that? That we have to see. If we increase, it becomes conductor. If we decrease, it becomes an insulator. So it behaves like a conductor as well as an insulator. Okay? Yes. Now, my dear NEET aspirants, listen to me very carefully. There is a concept that is called band diagram. Band diagram. Listen carefully, guys. Band diagram simply means, listen, let's suppose you have a material. You go at its atomic level. Then when you zoom, keep on zooming, you reach the atomic level. Over there you'll find, sir, a nucleus. Around the nucleus, electron is revolving. Electron is revolving in the orbits. Okay? Yes. Electron is revolving in the orbits. Now, my dear NEET aspirants, if you say, sir, this electron, this is the nucleus, and this electron is actually revolving in this orbit. Okay, this electron is revolving in this orbit. My dear NEET aspirants, in reality, these electrons are present. Listen to me very carefully. These electrons are present in energy levels. In reality, these electrons are present in energy levels. If you take a material, you go at its atomic level, you see electrons revolving. In reality, it is not like this. In reality, if you zoom, you see these electrons are present in energy levels like this, Okay. Okay. Yes. Energy levels. Now, in these base, sir, where did you get this? When you keep on zooming this one orbit, you get basically these energy levels. Inside this one orbit, you have a lot of energy levels. And in these energy levels, we say electrons are present, something like this, in pairs. This is what we call conduction band. Conduction band. And this is what we call valence band. This is conduction band and this is valence band. And this is called energy band gap. Energy band gap. Okay, this is called energy band gap. So when you check any material, if you go and if you keep on zooming it, you reach the atomic level, you see the orbit. When you keep on zooming the orbit, inside the orbit, you see these are the energy levels in which electrons are actually present. Then, my dear NEET aspirants, this band diagram for conductors will look something like different. For insulators, it will be different. For semiconductors, it will be different. My dear NEET aspirants, when we make the band diagram, listen carefully. If I make for conductors, for conducting materials, okay, like metals, this band diagram will look something like this. It will look something like this. Okay, something like this. Okay, this from here to here, it is conduction band. From here to here, it is valence band. Okay, these electrons will be filled in conduction band as well as in valence band. Completely filled. These are called free electrons. These are called bonded electrons. Okay, the electrons which are present inside the valence band, these are called bonded electrons. These are free electrons. Free electrons are those electrons which create the current, which constitute the current. Okay, which create the current. So because of this, current flows in the material. Not because of these, because these are bonded. Bonded means these are fixed. And if you say energy gap, that is zero here. No energy gap. And when you see for insulators, this band gap will look something like this. This is conduction band, this is valence band. Conduction band would be completely empty. That is the reason no current flows over here. And this would be over here, valence band, filled. And this energy band gap is very large. That's why no electron is able to reach conduction band. No electron can move from valence band to conduction band. Guys, smash the like button if you're not like the session yet. So that's why conduction here is zero. No free electron in the conduction band. Then band diagram first for semiconductors. Take a look. This is what we need to study. Now guys, this is the conduction band, this is valence band, this is energy band gap. At 0 Kelvin, listen carefully, no temperature is increased. Conduction band is completely empty. Conduction band of semiconductor is completely empty. This is not at 0 Kelvin. At 0 Kelvin, you assume it is completely empty. And valence band is completely filled. Valence band is completely filled, okay? And one more important thing. This is the lowest energy level of conduction band. Lowest energy level, minimum. This is the highest energy level, maximum energy level of valence band. Highest energy level of valence band. Now guys, if you increase the temperature, let's suppose we increase the temperature, what will happen? These electrons will gain energy. Bonded electrons will gain energy. They start vibrating. When they start vibrating, they will shift to the conduction band. They will move to the conduction band. Okay? When they move to the conduction band, my dear NEET aspirants, let's suppose we increase the temperature to 300 Kelvin. We say bonded electrons will move to the conduction band. Some bonded electrons will move to the conduction band. Now guys, when this electron moves to the conduction band, please listen carefully. When this moves to the conduction band, because they gained energy, what do you think? What will remain over here? Sir, nothing. So nothing means hole will be created over here. Hole. Electrons will be created here. Holes will be created over here. So we say electron hole pairs have been created. Electron hole pairs have been created. And my dear NEET aspirants, electrons have got negative charge. If negative charge leaves the place, what remains over there? Positive charge. Yes. Sir, does that mean holes have positive charge? Absolutely, holes have positive charge. If negative charge is present at a particular place, if that negative charge leaves the place, we say positive charge will be present at that particular point. Yes, I can say it something like that. Then, so electron hole pairs are created. Holes here, positive charge here, negative charge here. Directly remember, my dear NEET aspirants. Okay. Now we have types of semiconductors. Okay. First is intrinsic semiconductors, and then you have extrinsic semiconductors. These are also called pure semiconductors. These are called impure semiconductors. Pure and impure semiconductors. Okay. Yes. Now, my dear NEET aspirants, listen to me very carefully. This is the pure semiconductor in which no impurity is added. Sir, why do we add the impurity? To increase the conductivity. That I'll tell you after some time. Let's suppose if we take a pure semiconductor. This is a pure semiconductor. Now, pure semiconductor is this. Okay. It has some holes already created. Some electrons are already present in the conduction band. Now take a look. Now if I make this semiconductor over here, pure, it has some holes already. It has some electrons already. Now in a generalized way, we make it like this. And in actual scenario, it looks like this. Silicon. We take silicon material as a pure semiconductor. Germanium material as a pure semiconductor. Okay. Yes. Now, boys and girls, if I take the silicon over here, so silicon has actually 4 valence electrons. Okay. So basically, this is the silicon material. And in this silicon material, my dear NEET aspirants, I say it has got electrons also, it has got holes also. See, these are the holes. These are the holes. These are the electrons. Like here, generalized way, electrons as well as holes. When you connect a battery, this is the positive terminal or the negative terminal. So it will create positive charge here, negative charge here. So due to this positive and negative, electric field is set up from positive to negative. So battery basically sets up the electric field. So due to this battery, electric field is set up from where to where? From positive to negative. So in this silicon, electric field is set up from positive to negative in this particular case, my dear NEET aspirants. Okay. Okay. In this silicon, electric field is set up from positive to negative in this particular case. Absolutely. Okay. Now, my dear NEET aspirants, when you basically connect the battery, electric field is set up. Due to this electric field, guys, these electrons will experience the force in the opposite direction. We have studied when negative charge is placed in the external electric field, it experiences the force in the opposite direction. So this electron will move in the opposite direction and it will occupy this hole. When electron sees the hole, it gets occupied into the hole. Now, when this electron moves from here to here, okay, it is occupied into the hole. Now, hole moves, it looks like hole is moving from here to here. Now, here hole will be created. Because electron was here. If you move the electron from this point to this point, now hole will be created here. So, electrons move from left to right, right to left, and holes move from left to right. Now here, current is being produced due to the movement of electrons also, due to the movement of holes also. Because holes have got positive charge. If holes also move, current is being produced. If electrons also move, current is being produced. Now, if I say what is the net current produced in the pure semiconductor, this is the net current produced in the pure semiconductor. I net is equal to NIEA delta V divided by L. Delta V is the potential difference. Mu E is the mobility of electrons. Mu H is the mobility of holes, my dear NEET aspirants. Guys, this is not important. What is important that I'm going to tell you? If I say this is a pure semiconductor. You want to flow the current in the pure semiconductor. You connect a battery to it. Due to the battery, electrons will move as well as holes will move. This will be the value of the current which is produced in the pure semiconductor. But this current is not that huge current, my dear NEET aspirant. This is having a very less value, not that huge. Now see, in order to increase the conductivity of a current, we basically convert these intrinsic semiconductors to extrinsic semiconductors. This point is important. Why did I show you this? This is the current produced in the pure semiconductor. Value of this is very small. But if you want to increase its conductivity, you convert intrinsic semiconductor to extrinsic semiconductor. That means impure semiconductor. Okay. So, first and the foremost thing, we will be making the N-type semiconductor. This is an N-type semiconductor. Okay. First and the foremost thing, we will be making in this particular case N-type semiconductor. Okay. N-type semiconductor is basically an impure semiconductor, which I can say in this particular case, boys and girls. Okay. Yes. Now, what I want you to understand in this particular case, if somebody says, why do we have to make the semiconductor impure? That is extrinsic. It is because we need to increase the conductivity of the semiconductor, my dear NEET aspirants. That is the reason we are adding the impurity over here. Guys, tell me in the chats, is this clear till over here? In the chats, let me know, is this clear till over here? That's great. That's great. That's great. So, my dear NEET aspirants, I'll write over here, if the impurity is added to the semiconductor, if the impurity is added to the semiconductor, it becomes what? Extrinsic. Okay. And my dear NEET aspirants, when it comes to the N-type semiconductor, we use phosphorus impurity. We use phosphorus. Now listen carefully. We are taking a pure silicon crystal. This is a pure semiconductor. No impurity added at all. This is a pure semiconductor. Silicon. And silicon has got 4 valence electrons. Si has 4 valence electrons. What does that mean? That means whenever Si is in the crystal, it is stable. It is stable with 4 valence electrons. 1, 2, 3, and I would say in this particular case 4. This would be here. Okay. 1, 2, 3, and 4. This would be here. This one. 1, 2, 3, and this is 4. Silicon has got how many valence electrons? 4 valence electrons in order to fit into the crystal. Now, my dear NEET aspirants, when you add phosphorus impurity, you take a silicon crystal, you are adding the impurity to this. You are adding phosphorus impurity. Phosphorus is a pentavalent impurity. This is pentavalent. Pentavalent. Pentavalent means it has got 5 valence electrons. Like this has got 4. It has got 5. Now, when you basically add phosphorus, that is a pentavalent impurity. Now, in order to fit into the crystal, how many valence electrons it must have? 4 only. Because into this crystal, there is a place of 4 valence electrons only. So can I say, in order to fit into this crystal, phosphorus must have 4 valence electron only? Yes. So it has to lose 1. So this phosphorus will basically lose 1 electron. When it loses 1 electron, it becomes phosphorus positive. That means positive donor ion. Donor ion. So basically, my dear NEET aspirants, when you add phosphorus over here, so phosphorus, it will lose 1 electron. Now, after losing 1 electron, how many electrons it has? 4. So 1, 2, 3, and this 4. And 1 electron, which it has donated, that is over here. These electrons are considered as bonded, and this will be considered as free electron. Now see, so means you are adding 1 electron over here, that is that is a free electron. You are adding 1 phosphorus over here. Because of 1 phosphorus, 1 free electron is released. And because of free electrons, only current flows, conductivity increases. Now, if you add million phosphorus, guys, tell me one thing. If you add million phosphorus, on adding million phosphorus, how many electrons are released? Million electrons are released. So conductivity will increase by a large amount. So my dear NEET aspirants, this is how you create an N-type semiconductor. This is how you create an N-type semiconductor. Okay. Okay. So I can say in this particular case, so I will write on adding million phosphorus, million free electrons are released. So I can say conductivity increases. Because of free electrons, only conductivity increases. So tell me, my dear NEET aspirants, in this particular case, what is the majority charge carrier over here? Majority charge carriers will be the electrons in this particular case. Why, sir? Because electrons, see, you are adding impurity. Because of phosphorus, we say electrons have been increased. And what is the minority charge carriers? Arey guys, this is a pure semiconductor. This pure semiconductor will have some holes and electrons that we have already studied. Now, when you are adding phosphorus to this, number of electrons increase, number of holes will remain the same. It is like this. Let me show you with the help of band diagram. Let's suppose this is an N-type semiconductor. This is filled. Okay, this is valence band. These are the holes already created, 4 holes, and some 4 electrons are already present in pure semiconductor. When you added phosphorus, because of phosphorus, free electrons increased. 1, 2, 3, 4, 5, 6, and million. Now see, number of free electrons is majority charge carriers. Number of holes is minority. Minority will remain 4 only. Majority will increase in this particular case. Okay. And number of electrons is the majority charge carriers here. Number of holes is the minority charge carriers over here. Okay. Current due to electrons is much, much greater than current due to holes in this particular case. Okay. And one more important thing. Number of electrons is equal to number of donor ions. Donor ions means phosphorus. If you add 5 phosphorus, how many electrons will be released? 5. If you add 10 phosphorus, how many electrons will be released? 10. So whatever the number of donor ions, number of electrons. I hope this is crystalline clear. Then you have P-type semiconductor. In P-type semiconductor, you add boron. Boron is a trivalent impurity. Trivalent impurity. And here you take pure semiconductor as germanium. Germanium is also pure semiconductor. Now, my dear NEET aspirants, when you add trivalent impurity, that is boron. Okay, because boron is a trivalent impurity. It has 3 valence electrons. Trivalent means 3. In order to fit into this germanium crystal, how many electrons it must have? 4, but it has 3 only. So it will gain 1 electron, plus 1 electron. When it gains 1 electron, it becomes boron negative. That means negative acceptor ion. When you add this to the crystal, let's suppose this is boron over here, boron negative. Boron has only 3 valence electrons. Listen carefully. 1, 2, and 3. In order to fit into the crystal, okay, in order to fit into the crystal, I would say, listen carefully. In order to fit into the crystal, I would say it has to gain 1 electron. So this germanium into the crystal, it is going to give its own electron to the boron, because see, germanium is already present in the crystal. It has got 4 valence electrons. When you add boron, boron has only 3. So germanium is going to give 1 electron to the boron. It will give 1 electron to the boron. Now boron will have 4 valence electrons. That's why it became boron negative acceptor ion. Now, if this gives electron, a hole is created over here. Now, on adding 1 boron, how many holes are created? 1. On adding millions of boron, how many holes are created? Millions of holes. So here, tell me now, what is the majority charge carriers? Holes. What is the minority charge carriers? Electrons. Majority charge carriers is holes, minority charge carriers electron. Hole is the majority charge carrier, electron is the minority charge carrier. Number of holes is much greater than number of electrons. And number of acceptor ions, boron, is equal to number of holes. Yes, because due to 1 acceptor ion, 1 hole is created. Due to 1 boron, 1 hole is created. That's why number of acceptor ion is equal to number of holes. I hope this is crystal and clear, my dear NEET aspirants. Okay. So, in N-type semiconductor, pentavalent impurity is added. In P-type semiconductor, trivalent impurity is added. Okay. In N-type semiconductor, majority charge carriers are electrons, minority are holes. In P-type semiconductor, majority are holes, minority are electrons. Is this clear, or tell me in the chats, everybody? Now take a look at the question. Conductivity of a semiconductor increase on doping. Doping means adding the impurity. When you add phosphorus impurity, boron impurity, obviously conductivity increases. So this is correct. Doping raises the temperature. Doping, impurity, adding the impurity does not raise the temperature. So this is wrong. So assertion is correct. Reason is incorrect. So option C. Assertion, reason. For a given applied voltage, conduction current in N-type semiconductor is more than in P-type semiconductor. Guys, see, when it comes to N-type semiconductor, what is the majority charge carriers? Electrons. Electrons are lighter. They have got more mobility. Mobility of electrons is much greater than mobility of holes. Mobility of electrons is much greater than mobility of holes. See, if there is a lighter person with less mass and there is a person with huge mass, who is free to move? With less mass, the one who is lighter. Okay. So less is the mass, more is the mobility. So if mobility of electrons is more, so they will create more current. Current in electrons is much greater than current in as compared to holes. For a given applied voltage, current in N-type semiconductor. In N-type semiconductor, majority charge carriers are electrons, is more than in P-type semiconductor. Yes. Why? Because mobility of electrons is greater than mobility of holes. Yes, correct. Assertion is correct. Reason is correct. Reason is the correct assertion. Reason is the correct explanation of assertion. Guys, smash the like button. NEET 2019. Which of the following statements is correct? Electrons are majority carriers and trivalent. Okay, which of the statements is true for P-type semiconductor? Electrons are majority charge carriers. P-type, no. Holes are majority charge carriers. Holes are majority charge carriers and trivalent atoms are the dopants. Yes. Yes. Option B. Holes are majority charge carriers, pentavalent atoms are dopants. No. Boron is a trivalent impurity. This is also incorrect. Option B. Next, NEET 2013. In an N-type semiconductor, which of the following statements is true? Holes are majority charge carriers. No, incorrect. Electrons are majority charge carriers. Trivalent atoms are dopants. No, pentavalent atoms are dopants. Electrons are minority carriers. Pentavalent atoms are dopants. No. Holes are minority charge carriers. Pentavalent atoms are dopants. Yes. Oh, is this clear? Oh? Okay, PN junction diode. Guys, let's finish PN junction diode. Okay. Or do one thing, let's take a break. Break till 2 p.m. Okay. After the break, we'll finish this rest of the semiconductors and optics. Guys, smash the like button if you're not like the session. Come on, do it quick. Okay, let's move on to the PN junction diode. Let's move on to the PN junction diode. Everybody of you listen to me very, very, very carefully. Now see, we say this is a P-type semiconductor and this is an N-type semiconductor. Listen carefully. I'm going to make it like this now. In P-type semiconductor, what is the majority charge carriers and what is the minority charge carriers? Minority charge carriers. Sir, in P-type semiconductor, majority is holes. Okay. And in N-type semiconductor, majority is electrons. It is mentioned over here. Okay. These are the majority charge carriers. And what is this negative? Negative is the boron. Negative acceptor ion. This is the fixed ions. Because in P-type semiconductor, what did you add? You added boron, negative acceptor ion. Huh? You added boron. Yes. Just a second. Okay. Now. Am I audible now? Yes. Now take a look. Now guys, see, we say when it comes to the PN junction diode, P-type semiconductor is connected to N-type semiconductor. In PN junction diode, we say P-type semiconductor is connected to N-type semiconductor. And in P-type semiconductor, majority charge carriers are these holes. And this is the negative acceptor, negative fixed ions. Negative acceptor ions, boron. Because if you add 5 boron, five holes are created. Similarly, from this side, this is phosphorus positive. Now, my dear NEET aspirants, when you join P and N side, these electrons see holes. When you join P and N side, these electrons see holes. So these electrons will transfer to the holes. When the electrons transfer to the holes, my dear NEET aspirants, then we say the depletion region is created. Because now guys, if these electrons have transferred here, what remains here? Positive charge. From this side, negative. So that's what I'm saying. From this side, negative, and from this side, positive. This region is what we call the depletion region. This is called depletion region. Okay. And in this depletion region, electric field is set up from positive charge to negative charge. So when P-type semiconductor and N-type semiconductor are joined together, it forms P-N junction diode. So this is P-N junction diode. This. And depletion region is created over here. Now, my dear NEET aspirants, in this particular case, listen carefully. I want you guys to understand one thing. We say electron hole recombination takes place over here. Electron moves to the holes. This is what we call electron hole recombination takes place over here. Now, my dear NEET aspirants, when these electrons move from here to here, current is produced. When electrons move from N side to P side, current is produced. Okay. And that current is called diffusion current. I diffusion is produced due to the recombination of electrons and holes. When electrons move from N side to P side, current is being produced. That's called a diffusion current. Okay. Okay. Yes. And my dear NEET aspirants, listen. If we say due to the motion of electrons, current which is being produced is called diffusion current. Okay. Yes. Then we have I drift. I drift is the current which is produced. Okay. I drift is the current which is produced due to the minority. Let me just make you understand in this particular case, my dear NEET aspirants. We say electric field is set up over here. Okay. And in this particular case, my dear NEET aspirants, when electric field is set up from, I would say, positive charge to negative charge. Okay. Yes. In the depletion region. Due to this electric field, minority charge carriers move. What is minority charge carrier? Guys, please. Majority charge carrier is electron and hole. Due to these majority charge carriers, we say diffusion current is there. Due to minority charge carriers, my dear NEET aspirants, minority charge carrier, what is the minority in P-type semiconductor? We say electrons. What is the minority here? Holes. Now, when these minority move, we say drift current is being produced. Directly remember, due to the majority charge carriers, diffusion current is there. Due to the minority charge carriers, drift current is there. And this diffusion current will be equals to the drift current, so net current will be 0. In case of PN junction, we say net current will be 0. That's it. Guys, what is PN junction? When P side and N side are connected to each other, depletion region is created in that case. We say this is what we call PN junction diode. Now see, what is important here is forward bias. Please take a look. What is important is forward bias. Let's suppose this is PN junction diode. P-type semiconductor is connected to N-type semiconductor. This is the depletion region. Now you have connected a battery. You have connected a battery over here, my dear NEET aspirants. You have connected a battery. This is the positive terminal of the battery. This is the negative terminal of the battery. This is the positive terminal of the battery. This is the negative terminal of the battery. Okay. Absolutely, sir. 100%, sir. What I want you to understand in this particular case, boys and girls, if this is the positive terminal of the battery connected to P side, negative terminal of the battery is connected to N side, this is called forward bias. Directly remember. And my dear NEET aspirants, holes have got positive charge. If due to the battery also positive charge will be occupied over here, negative charge will be occupied over here. We say due to this positive charge, these holes are being pushed. Due to this negative charge, these electrons are being pushed. So now we say depletion region will decrease. Are you getting me? Depletion region will decrease. So when depletion region decreases, my dear NEET aspirants, when the depletion region decreases, the electron of the N side and holes of the P side will start recombining. What I'm trying to say is that, guys, in case of forward bias, positive terminal of the battery is connected to P side, negative terminal of the battery is connected to N side. This positive charge will push these holes. This negative charge will push these electrons because negative repel. We said depletion region will decrease. When depletion region decreases, now these electrons will see holes. Now we say they will again start recombining. When they again start recombining, when this electron moves here, now will it stop over here? No, it will flow through this wire. It will flow through this wire, and again will reach the end side. Again it will move to this. Again it will flow through the battery. So this is the procedure of current flow in the forward bias. That's it. This is the procedure of current flow in the forward bias. Okay. Okay. What I'm trying to say is that, my dear NEET aspirants, what I'm trying to say is that when depletion region in forward bias decreases, electrons of this side move to this side. Then they will not stop here. They will flow through the battery and will come back to the end side over here. Tell me in the chats, is this clear? Quick. Tell me in the chats, is this clear? Is this clear? That's great. That's great. So this is the procedure of forward current. This is the procedure of current flow in the forward bias. And if you make the graph, in case of forward bias, the graph is something like this. This would be the graph. This would be the graph. This is the graph of current versus voltage. And in the forward bias, current is very large. Current flows through by a large amount. And guys, this is the symbol of PN junction diode. This is the symbol of PN junction diode. When this P side is connected to positive terminal, N side is connected to negative terminal. This is called a forward bias. And in case of forward bias, my dear NEET aspirants, we say this diode behaves like a simple wire. Current will easily flow. And we say resistance, we assume 0 over here. 0 resistance, current will flow easily in this particular case. Now guys, let's move on to the reverse bias. Let's move on to the reverse bias. When I say this is a PN junction diode, this is P side, this is N side. P side is connected to positive terminal. Okay, sorry, negative terminal. This is negative right now. And this is negative right now. And this is positive. And N side is connected to positive terminal. This is called a reverse bias. So this is going to occupy negative charge on this side. This is going to occupy positive charge on this side. Now tell me, this negative charge is going to attract these holes towards itself. This positive charge is going to attract these electrons itself. So we say here in this particular case, depletion region increases. In this particular case, depletion region increases. So if depletion region increases, do you think that electron and holes will recombine? No, sir. So we say in this particular case, current will not flow. Directly remember, current will not flow in this particular case. Okay, current will not flow in this particular case. So I can directly say, you directly remember one thing. When it comes to the reverse bias, diode behaves like an open wire. Because resistance is infinite, in this particular case, you almost say current is 0. So this is the symbol. Here, this diode, it is connected to negative terminal. This N side is connected to positive terminal. Guys, when it comes to PN junction diode, as forward bias, positive terminal is connected to positive potential. Positive terminal is connected to P side. Negative terminal is connected to N side. And when positive terminal is connected to N side, negative terminal is connected to P side, that is reverse bias. In forward bias, current can flow easily. In reverse bias, current will not flow. In forward bias, diode behaves like an simple wire. In reverse bias, diode behaves like an open wire. Means current will not flow. Now take a look, my dear NEET aspirants. First question. In an unbiased PN junction, holes diffuse from P region to N region. Unbiased. Unbiased is this. This is unbiased. We say holes diffuse from P to N, electrons diffuse from N to P. Okay, holes diffuse from P region to N region, correct? Because hole concentration in P region is more as compared to N region. Obviously, assertion is correct, reason is correct, reason is the correct explanation of assertion. Next. The increase, NEET 2020, the increase in the width of the depletion region in PN junction diode is due to, increase in the depletion region is due to what? Increase in the depletion region is due to what? That is reverse bias. Due to reverse bias, increase in the depletion region, that I told you recently. Next, NEET 2017. Which of the following diodes is forward biased? Now guys, see. This is P side, this is N side. Positive potential means higher potential, negative means lower potential. So if P side is connected to higher potential, then it is forward bias, else reverse bias. N side is connected to 5. This is higher potential. This is lower potential. So means this is reverse bias. This is PN. P side is connected to 0. N side is connected to minus. This is forward bias. Because this is higher potential, this is lower potential. Okay, what about this one? This is P side. This is N side. This is lower potential. No. This is higher. This is lower. Why? Because this is minus 4. This is reverse bias. This is PN. This is also reverse bias. We are supposed to find out which of the following diode is forward bias. Option B. Yes, that's great. What about this one? Two ideal diodes are connected to a battery as shown in the figure. We are supposed to find the current. Guys, see. In this particular case, this is N side. This is N and this is P. This is P and this is N. Now P is connected to higher, N is connected to lower. So this is forward bias. Forward bias. This one is reverse bias. In reverse bias, it behaves like an open wire. So you remove this, so it will look like this. So instead of this, you make a simple wire. Instead of this, you make an open wire. Remove this. So this is 10 ohm resistance. This one I am making. And this is 5 volt battery. So I is equal to V divided by R. V is 5 divided by 10. That is 1 by 2 ampere. Okay. Which of the following diodes is forward bias? Tell me. This is P side, this is N side. This is P, this is N. This is P, this is N. This is P, this is N. Okay. This is connected to 0. This is connected to minus 2. This is forward bias. Okay. This is reverse bias. Minus 2, minus 5. This is reverse bias. This is reverse bias. Yes, A is the correct option. NEET 2016. NEET 2016. In this particular case, the current through the resistance R1. In this resistance, you have to find the current in this case. Guys, this is the positive terminal of the battery. This is negative. This is connected to N side over here. So means this is reverse bias. If this is reverse bias, you will have to remove this resistance. Remove this. So the circuit will look something like this. And then you have to make this. Guys, what about this one? This positive is connected to this, so it will behave like a simple wire. So 2 ohm, 2 ohm, and this is 10 volt battery. Now tell me, how much will be the current? I is V by R. V is 10 volts, R is 4. So 10 by 4, that is 2.5 ampere. Is this clear? Oh? This is your homework. Please do this from your end. Now comes Boolean algebra, that is logic gates. Is this clear? I need the signal in the chats. Now we have logic gates. Is this clear, or tell me in the chats, everybody? Smash the like button if you're not liked the session yet. That's great. Now guys, take a look. Before understanding logic gates, let me make you understand. Let's suppose we have a device over here. This is a device that we have. Okay, this is a device that we have. This is a device that we have. And this device, in this device, we give some input and it gives us some output. In this device, we basically provided some input. It gives us some output. What is the input that we provide over here? That is called the digital signal. This input and output, this is what we call as digital signal. Input slash output. This is called as digital signal. And this digital signal will be in the form of zeros and ones. Either it can be 0 or it will be 1. 0 also means 0 volts. 1 also means 5 volts. Or you can say low, it is high. Off, it is on. This is how you basically say it. This is how you basically say it. This digital signal. Now, my dear NEET aspirants, let's suppose, okay, one more important thing. First, in this Boolean algebra, we will understand addition, multiplication, and inverse. Like in Boolean algebra of what? Zeros and ones. Like in normal algebra, you study addition, subtraction, multiplication. In Boolean algebra, you have addition, multiplication, and inverse. Now see. We have, and we do addition of zeros and ones only. Let's suppose we have 0 plus 0, low plus low. What is low plus low? That is low. 0 plus 0 is 0. We have 0 plus 1, that is 1. Low plus high is high. 1 plus 1 is 1. Okay, if you have a plus 0, sir, but you said it will be only zeros and ones. A can be either 0 or 1. So you say a plus 0. Sir, what is the value of a plus 0? See, a can be either 0 or 1. If we keep a is equal to 1, so 1 plus 0, it will be 1. If you keep a as 0, 0 plus 0, it will be 0. So answer is coming out to be both. Okay, in this particular case. Answer is coming a plus 0. 1 plus 0 is 1. 0 plus 0 is 0. So answer in this particular comes out to be both over here. That is 1 and 0. Means you can say answer is A. Answer is A. If I say, guys, this one, next one. This one. A plus 1. A plus 1. If you keep A as 1, 1 plus 1 will be 1. If you keep A as 0, 0 plus 1 is 1. So in both the cases, answer is 1. So final answer will be 1. That's why I'm mentioning 1 over here, not A. Now directly remember, A plus A bar. Okay, A bar. What is A bar? Let's suppose you have 1. If you put the bar, it means inverse of 1. Inverse of 1 is 0. Okay, inverse of 0 has to be 1 then. Yes. A. If I say A bar means reverse of A. Even if you put A double bar will be A. A double bar will be. Okay, so if you say A plus A bar, it will be 1. Like over here. Now take a look. 0 into 0 is 0. 0 into 1 is 0. 1 into 1 is 1. A into 0 is 0. A into 1 is A. A into A bar is 0. This you need to keep in your mind. Now, De Morgan's law. De Morgan's law says that if you have A plus B whole bar, if you want to break this bar, so you can break this bar, A bar, B bar, but you need to change this sign from addition to multiplication. Okay. Yes. Or it can be like this. A dot B bar. If you break this bar, A bar, B bar, but change this sign to addition. Similarly, if you have commutative law means simply A plus B will be equals to B plus A. A plus B will be equals to B plus A. This is called commutative law. Then you have associative law. Associative law means A plus B, A plus bracket B plus C is equal to A plus B bracket plus C. Distributive law. A into B plus C is equal to A into B plus A into C. Basic things you need to keep in your mind. Now guys, listen carefully. Important in this case is gates. Logic gates. Gate is a device in which we give some input. It provides you the output. Just a second, guys. Now guys, take a look. We say there are 3 types of gates. There are 3 types of gates. NOT gate, OR gate, AND gate. These are the fundamental gates. Then you have universal gates, NAND and NOR. First, let's talk about NOT gate. NOT gate is the gate. NOT gate is basically that gate which has the work of doing inverse. Its symbol is this. This is the symbol of NOT gate. Let's suppose if you give some input to this, A, it will do its inverse. So output will be A bar. So Y is equal to A bar. Let's make the truth table. Truth table means relation between input and output. What will you give as input? What it is going to give you as output. Okay? Yes. Now take a look. If I say input is A, output will be A bar. Let's suppose you give 0, it will give you as 1. If you give 1, it will give you as 0. Okay. Electrical equivalent circuit of NOT gate. That circuit which exactly behaves like NOT gate. Now see this circuit. You have a battery, you have a bulb, and you have a key switch. See, I'll make its truth table. Input, output. Key, bulb. Key and bulb. Key will be considered as input. Bulb will be considered as output. Let's suppose if you keep the key on, 0 off. Keep this key off, 0. Don't connect it. Don't connect it. So means the current will leave from this. The current will leave from this, and it will flow through this bulb only. Bulb will remain on. That means 1. On means 1. 0 means off. If you keep this on, now join this. So current always prefers that path in which there is less resistance. So less resistance path is this. So means this remains off. That is 0. Now you compare this and this. Is it exactly the same? Yes. So this circuit exactly behaves like NOT gate. Then the second you have OR gate. Second one is which gate? OR gate. Okay. Now what is the work of OR gate? The work of OR gate is to basically add. Its job is to do the addition. The work of OR gate, its job is to do what? Addition. Its work is to do addition. Okay. Sir, what is the symbol of this gate? Take a look, guys. What is the symbol of this gate? Symbol of this gate is this one. This is the symbol. In which you give in which you give A and B as input, and output would be A plus B. Y is equal to A plus B. Now, if I say, what is the truth table? Truth table is if this is 0, this is 0. So 0 plus 0 is 0. Output would be 0. If this is 1, this is 0. So I would say in this particular case, 1 plus 0 is 1. This would be 1. If this is 0, this is 1. 0 plus 1 is 1. 1 plus 1 is 1. This would be the truth table in this particular case. Okay. Now in this case, my dear NEET aspirants, what I can say, electrical equivalent circuit of OR gate. And one more important thing I just want to mention over here. Output is low when both the inputs are low. This also you need to mention. Output is low when both the inputs are low. Output is low when both the inputs are low. And output is high. You see 1, 1 and 1. Okay. When any of the two inputs is high. When any of the two inputs is high. Are you getting me? If any of the two inputs is high, we say output is high. I'll write over here. Output is high if any of the two inputs is high. Output is high if any of the two inputs is high. I think there is no confusion in this one. Then electrical equivalent circuit of OR gate. That gate which exactly, that circuit which exactly behaves like OR gate. Now take a look in this case, guys. What I can say, this is a bulb over here. This is a bulb over here. And in this bulb, you have key 1 and key 2. You have K1 and K2 connected. And my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. Take a look, boys and girls. Take a look. See, in this particular case, you can clearly see over here, this is K1 and this is K2, key 1 and key 2. What I can say in this particular case, boys and girls, if you keep this key off means open, and this key also has off, so we say the current will come, it cannot cross. Current cannot cross, it cannot flow through this path, bulb remains off. When this is off, this is off, this is off. Cool. So means 0, 0, 1, 0, 0, 0. When you keep this as on, means this is connected, then current can flow through this path and bulb remains on, off, on. When you keep this as off and this as on, then current will flow through this path. So off, on, and bulb will remain on. When this is on, current can flow through this path also, bulb remains on. Now, what will you say in this particular case, boys and girls? Tell me. What will you say? We say output is low when both the inputs are low, and output is high when any of the two inputs is high. On, and on. So this truth table exactly matches with this. So I can say this circuit behaves like an OR gate. Then AND gate is, this is the symbol of AND gate. Its job is to do multiplication, A dot B. So this is 0, 0, 0, 1, 1, 0. 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. You can say it like this. Okay. Then, my dear NEET aspirants, electrical equivalent circuit of AND gate. This circuit behaves like an AND gate. This is K1, K2. When this is on, okay, this is off. Or when both are off, let's keep both off. 0, 0, 1, 0, 0, 0, off, off, off. Okay. And when this is on, but this is off, current cannot flow through this bulb, so bulb remains off. When this is off, this is on, so current cannot flow. So basically both has to be on in this case in order to flow the current through the bulb. So on, and on. What will you say? Guys, take a look. Output is low when any of the two inputs is low. When any of the two inputs is low, output is low. And output is high. Output is high when both the inputs are high. Now see here, exactly matching. Output is high when both the inputs are high. Output is low when any of the two inputs is low. Means this circuit exactly behaves like OR gate. This circuit behaves like OR gate. Then you have NOR. Then you have NOR. NOR gate simply means it is OR plus NOT. This becomes NOR. OR plus NOT becomes NOR. Okay. Now guys, see, in this particular case, this is OR gate, this is NOT gate. The work of this OR gate is to do the addition. So A and B, if you are sending, so it will do the addition, A plus B. And then this NOT gate, its job is to do the inverse. So this A plus B will go as an input in this. So this will do the inverse, that is A plus B bar. Circuit symbol, overall, we write it like this. Instead of this NOT, we just put the ball over here. This becomes NOR. And what is the final output of NOR? A plus B bar. This is the final output. If you make the truth table would be like this. 0, 0, 0 plus 0 is 0, and 0 bar is 1. 0 plus 1 is 1, 1 bar is 0. 1 plus 0 is 1, 1 bar is 0. 1 plus 1 is 1, 1 bar is 0. Now see here, output is high when both the inputs are low. Output is high when both the inputs are low. And output is low when any of the two inputs is high. Output is low when any of the two inputs is high. This is for NAND gate. Electrical equivalent circuit for NOR gate. Sorry, not NAND, NOR. This one. Now guys, see, if the current leaves from this circuit, if you keep this off, still current can flow through this path, bulb remains on. Off, off, on. If you keep this as on, so current will prefer this path because no resistance is through this path. So bulb remains off. On, off, off. If you keep this on, so current will prefer this path. Bulb remains off. If you keep both on, so current will prefer this path, but bulb remains off. Okay? If you keep this first one off and this one on, if you keep this off, this on, current will prefer this path, bulb remains off. Now see, output is low when any of the two inputs is high. Exactly like this. And output is high when both the inputs are low. Output is high when both the inputs are low. This is NAND gate. This is NOR gate. Then you have NAND gate. NAND is simply AND plus NOT. Okay. AND plus NOT. Now guys, this is AND. Its job is to do multiplication, A dot B. This is NOT. Its job is to put the bar, A dot B, and then you put the bar. Its job is to do multiplication. Then that will go as an input in this one. Its job is to put the bar. And if you make the truth table, 0, 0, 0 into 0 is 0, 0 bar is 1. 0 into 1 is 0, 0 bar is 1. 1 into 0 is 0, 0 bar is 1. 1 into 1 is 1, 1 bar is 0. So final output is going to be this one. This is the final circuit symbol, This is the electrical equivalent circuit of this NAND. Let's make its truth table. This is K1, this is K2, and this is bulb. K1. If this is on, this is off. On, off. So current cannot flow through this path, current has to flow through this bulb, on. If this is off, this is on. Off, on. Still current cannot flow through this path, current will flow through the bulb, on. If both are off, bulb remains on. If both are on, bulb remains off. See here, output is high when any of the two inputs is low. Output is low when both the inputs are high. Now see here, output is high when any of the two inputs is low. Output is low when both the inputs are high. Okay, absolutely. NEET 2016. What is the output Y in the following circuit if all the three inputs are first 0 then 1? It says this is AB. This is which gate? Tell me. Here I have shown you AND gate. AND gate is multiplication, A dot B. Its job is to do multiplication, so it will multiply A and B because input is A and B, and this C over here. This is NAND gate because ball is here. So its job is to multiply and put the bar. So final output would be A, B, and C, then bar. It says first put all the three inputs as 0. It would be 0 into 0 into 0 bar. That would be 0 bar. That would be 1. Then it says put all the three inputs as 1. 1 into 1 into 1. It is going to be 1. That is going to be 0, 1, 0. What about this one? This is a circuit. You have to tell me which gate is this actually. It's like this. This is 0, 1, 0, 1. Okay, leave the 0, 1, 0. This is a bulb. This is resistance. This is resistance. This is plus 6 volts. This is 0. Now this is K1 and this is K2. Now guys, if you have to figure out which gate is this, you make its truth table. K1, K2, and this is bulb. K1, K2, and this is bulb. Now, my dear NEET aspirants, what I can say in this particular case, if this is K1, K2, and this is bulb, we say current will flow from higher potential to lower potential. If let's suppose current moves like this, if you keep this on, this as off, on, off, that means on means 1, 0. So this is on, this is off. So current will not flow through this path. Current has to flow through the bulb. Bulb remains on is 1. If you keep this one as off, this as on, still current cannot pass this one. Current has to flow through the bulb. Bulb remains on. If you keep this off, this as off, bulb will again remain on. If you keep this on, current will flow through this path and bulb remain this off. Output is high when any of the two inputs is low. Or tell me which gate is this? Output is low when both the inputs are high. Output is low when both the inputs are high. Output is low when both the inputs are high. Which gate is this? NAND gate, bro. NAND gate, bro. Okay, tell me what about this one? Let me make the diagram here. This is 0 volt because this is earthing plus 6 volt. This is R, this is bulb. This is K1, this is K2. Now tell me, which gate is this? Make the truth table. Make the truth table. Can you make it? Can you make it? Tell me. K1, K2 and bulb. K1, K2 and bulb. K1, K2 and bulb. Guys, if you keep this as on, 1. This one as off, 0. Then current will not flow through this path. Current will prefer this path. Guys, this is an interesting question. Current will prefer this path. Bulb remains off. This is 0. If you keep this as off, this as on, so current will prefer this path. Bulb remains off. If you keep both on, bulb remains off. If you keep this off, current has only one path, that is through the bulb. Off, off, on. Now see, output is low when both the inputs are, output is high when both the inputs are low. Output is high when both the inputs are low. Output is low when output is low when both the inputs are high. Output is high. Output is no. Wait. Sorry. Output is low when any of the two inputs is high. Output is low when any of the two inputs is low. Output is low when any of the two inputs is high. Output is low when any of the two inputs is high. Nor. It is nor. Nor. Clear? Oh? Yes. Nor. It is not NAND. NOR gate. So what about this one? NEET 2018. Can you find the answer of this? This is A. This is B. And you will be putting over here B bar. A and B bar. Now it will do what? A B bar. Because it will do multiplication. Because this is what gate? AND gate. Its job is to do multiplication. Now this is A. This A will go here also. This not. It will do the inverse A bar. And this B as it is. Again A bar into B. Now this one, this is OR. Its job is to do addition. This AND. This OR. So I would say its job is to do addition. So this will go as input. This will go as input. So it will do add. So A bar B plus A bar B. AB bar plus A bar B. This will be the final output. This is going to be the final output. Okay. Is that clear? Is that clear, boys and girls? Is that clear? Now, guys, that's great. Let's do one thing. I'm not feeling well today, okay? Because I have too much cough. Can we take one more part 4? Can we take part 4 of this, in which we'll complete SHM, waves, optics, and AC? These 3 chapters. Can we do that? Part 5, because this was part 4, part 5. In total, part 5. Can we do that? Okay. So then that's all for today, guys. Thank you so much. We'll come up with one more part in which I'll complete those 3 chapters. Okay. That's all for today. Okay. Yes, I'll share the notes. Take care and bye-bye. Thank you. Bye-bye.